I'm Justin from Toolpath, and with me today is Alex Rosner, Wisconsin Cam on Instagram. Thanks for joining me today, Alex.
Yeah, thanks for having me.
Yeah.
A lot of you probably know me for my Brother Speedio videos or the Hermley swinging that thing around.
Tool set racing, right?
Everything's a race.
I've been wanting to have you on for a while. We talk a lot offline about really bad ideas of things to do in our shop that turn out to work pretty well. So today's a discussion about ideas that are so bad they come back around to being good. We're just going to jump around from topic to topic here. I want to start by talking about tool setting, actually, and your tool set racing and probing macros in general. So some folks might know that I actually wrote the macros, wrote my own probing macros for my style. The reason I did that was really dumb. When I ordered it, they told me that the factory probing macros would only work with their probe, and I didn't want to buy their probe. And I didn't know enough to know any better, so I bought a Tormount probe, wired at the time. Actually, I think I started with a Drewtronics probe. Yeah, anyway, a wired probe, and I started writing my own probing macros because I assumed they wouldn't work. The factory ones are really poorly written anyway, and they have like Chinese comments in them and stuff. So I don't really regret it, but it was a surprising amount of work. And I think the worst part about it was that like for, 5 months, every time I would make a part that needed, like I'm in the middle of making a customer part and I have to stop what I'm doing to write a probing macro because I didn't have like probe off a corner or probe off a bore or probe off the outside of a boss written yet. So for months, it was a pretty big interruption. Yeah. But I didn't think I really had much of another choice. The other thing that's really scary about writing macros is, I don't know, I seem to crash a lot when I'm developing probing macros. So that was my sort of first foray into macros, and it was on my first CNC machine. But you took a different path. You wrote new tool setting macros for the Speedio because the ones that came from Bloom weren't good enough. What led you down that road?
They're really slow, difficult to use. They weren't giving me the options I wanted. I probably would have been better served modifying them, but I did a ground up rewrite. The scope on tool setting macros is significantly smaller than probing, like with a spindle probe for work offsets. So I did it in a few hours, and it's really not much to worry about. I also did multi-insert touch, any number of inserts, and you can adjust the like starting clock. So it doesn't matter if you're like lucky and the tool goes in the spindle with an insert that would be oriented over the setter. Because the only assumption is that all the inserts are evenly spaced. But I've never seen a tool that was significantly different.
Yeah, I mean, I think there is some tools have a small stagger in the spacing. There are even like if you have an odd number of inserts, then if you load the tool like 180 degrees out of phase, then the angle can change. I think, is it cat tool holders that can only go in one way? I know the HSK ones are directional.
Cat, there is like a different notch both ways, but a lot of machines will take it both ways.
Oh, okay.
BT doesn't care. HSK is only one way.
Yeah. I think for that reason, I would prefer a spindle that was only one way. I actually also wrote a multi-touch probing macro for face mills on the Speedio. So on the like Renishaw and Haas, they'll do the like spin backwards thing.
I really don't like that.
You don't like it? It confuses the heck out of me. Like from a physics standpoint, I don't know how you can guarantee that you don't like tap the side of the tool setter. Now, I mean, it's not harmful on the Renishaw ones because it has, like sideways motion. But I just don't know how you can guarantee accuracy.
I think you don't. And it is carbide on carbide. So if you have like really fragile aluminum inserts with a bunch of rake on them and a polished edge, and you're spinning that backwards against the carbide anvil on the setter or the stylus, I just don't like it. And I have the Bloom Z Nano, which has only Z stroke anyway, so there's no real option for that. But I think it's way more reliable to do you clock the spindle, orient it, touch and insert, insert, rotate, rotate. Each insert, and you could do it however you wanted. You could take the highest, the lowest, the average. I'm taking the highest because that's what you're going to actually cut into your part with.
Highest being the largest number.
Yeah, whatever is, I guess you'd say the longest length. Everything I'm going to say today is based off of real positive gauge length tool offsets.
Got it.
Like the only way you should be running any machine, but I guess that's not a given.
Yeah, I don't understand. Like I've never like really thought through like the negative offset stuff. I don't understand it, but I guess to each his own.
I've been around an environment where they didn't use G54Z at all, and every tool was touched off the top of your part with like a massive negative Z height. And then if you changed your part at all, every tool had to be changed. It was ridiculous.
Wow. Yeah. That sounds incredibly frustrating.
This is like when boomers learned how to do CNC 30 years ago and then refused to change.
Yeah, I mean, even when I was doing manual tool setting, I used like when I first got my Sile, I didn't have a tool setter, like an electronic one. So I used the 1, 2, 3 block gauge tool method where you zero against a 1, 2, 3 block and with a known gauge tool length. And then you come down and like use paper or whatever to set your tool. So I would still get like a real positive length that was independent of my work holding or anything. I don't understand why you'd do it any other way. There must be some like implicit advantage other than maybe it's just simple to explain to negative tool offsets. I don't know. I can't figure it out though.
It's always been real intuitive for me, and I like that. Well, I only have one machine for B230 and one for HSK, but if you are doing it this way, you could change tools between machines and it would always work.
Right. Or if the same as if you're using a presetter, then you would need to use positive gauge length offsets. Yeah. So I also wrote a multi-touch face mill thing. I did it out of like pure frustration. We actually don't use face mills very often here. Well, I should say we didn't. We started using them more, mostly to get nice cosmetic finishes on swag when we give it out. But they're kind of a pain in the butt in a job shop because you never know if the inserts are good. And then, like you said, if you just touch off like one insert, you don't know that you have like the true height of the tool. And because we don't use our face mills very often, also, at the time, I only had one face mill, which is a ridiculous face mill. I bought it on sale when Titan was selling those dodeca face mills, but I didn't act quickly. So like all the 1-inch and 2-inch face mills had already sold. So I was like, all right, well, it's cheap. I'll buy a 3-inch dodeca face mill. What's the difference? So not only is that tool way too big for a BT30 spindle just to like kind of take any kind of meaningful cut with it. That's fine if you're just trying to face. But having such a big face mill also like really restricts the size part you can use it on in a machine with 500 millimeters of travel. So I don't think I'd buy that face mill again. But anyway, because we didn't use it very much, we didn't take great care of it. And it had been sitting assembled on the shelf, but banged into stuff or taken too hard of cuts or whatever, thrown a few parts. So Ben picked it up one day and tried to use it to make, actually, I think it was the IMTS keychains that we were handing out. And he cut the part and it came out. He was doing like really shallow engraving on it, I think like 2 thou or something. And the engraving didn't show up at all. And so by the time he had finished comping it in, he had to drop the tool length like 8 thou or something, increase the height of the engraving tool. And I was like, 8 thou is way too much. Don't quote me on that number. It could have been like 6 thou or 5. I don't know. It was a lot. I was like, the face mill must be off. So I went and manually just like touched off each individual insert and just wrote down the numbers. And sure enough, like one of them was off by like 5 thou somehow. But at that point, I had already like gotten a good read on it. And so I was like, just use this with this new height, plug this in for the tool and you should be fine. and that solved that problem. But that took me, I don't know, 15 minutes or something to touch off 5 inserts, write down the numbers, figure out what the biggest one, maybe not 15 minutes, but felt like an eternity. I got really annoyed. And so after that, I was like, screw it. And I wrote a macro to touch it off. But then I remembered that you had written one. So you were kind enough to share yours with me, and it's much more nicely written than mine. So I applaud you for taking the time to write a good macro. And I think you're ready to release those open source, right?
Yeah, we're going to clean it up a little bit, add some more comments, and maybe we'll write like a quick install guide and how to use like Word document. So it's actually useful to people that aren't dorks that could have just written their own to begin with. But yeah, I'm going to give it away for free. I'm sick of trying to sell it. It's not worth my time.
Cool. So for the Speedio users out there, you'll have some pretty good tool setting macros to use.
It would be a solid framework to convert it to another control type.
Yeah.
The Brother G code is very, very analogous to FANUC macro B. You just have to like convert the macro variables for where it's writing tool offsets and storing the calibration values and stuff.
Right. Yeah, for sure. When I wrote my macros, it was the first time I'd ever actually gotten community contributions to an open source project. I mean, we had some when I was doing open source stuff at NASA, but this time, surprisingly, Josh Smith, who's not on Instagram, but does have a small YouTube channel and is on Facebook, like grabbed my macros and completely rewrote them from scratch and made them a lot better. Made kind of a generic settings file, added a lot more comments. And then a couple of other people chimed in and gave really helpful tips. But in the spirit of ideas that are so bad that they come back around to being good. And my first probing macros that I wrote, I didn't know that, at least on the SILE, there's a G code that you can specify to make it, it's actually not a G code, but anyway, there's a command, a function you can call to make it ignore the feed and speed overrides.
Brother has a code for that too.
Yeah. So I'm guessing that most machines have it, but so I didn't know that. And somebody was like, hey, you really should add this in before the probing step, because obviously the speed at which you probe should be consistent to get an accurate result. So they added that in, they restructured the macros, and now they're in pretty good shape. But the worst part about, the most annoying part about that whole process for me was that there are 2 ways that you can load macro files onto that control. The first is you can have named files in your current active working directory on the SILE control. I hate that you can't do that on the Brother control, but whatever. And so I named all of my probing macros, and then I keep like the named files, which I call as subprograms, in the MDI screen. So they're really easy to identify, like probe bore, probe corner, probe Z, probe X, etc. But there's another way you can store the macros, where you put them in a folder. They have to be like numbered programs. And a bunch of people really wanted that, because then you can call them from any folder structure you want on the control. Versus when they're named, they have to be in your current active directory. And I just could not bring myself to like number all the programs. And like when I was staring at them, like, because they call each other, there's a bunch of subprogram calls and everything. Like probe web is called for, probe X web, and probe Y web are called for like probing a square block and things like that. And I wanted that to be readable. So I just steadfastly refused to convert over to this maker macro format that the SILE uses. But then finally one day, I think it was Josh Smith, he poked me about it, and I was in a weird mood, and I was like, you know what, fine, I'm going to deal with this. And so I wrote a Python script that parses all of my macro files and does like a text replace on names to numbers. And so now I code all the macros in what I would consider mostly human readable format. And then I call a Python program to convert them into the maker macro format. I thought that was a pretty slick way to do it, to write essentially a post processor for my macros.
This is like the beginning step at something else we've discussed, which is like making a macro programming language in IDE and compiler, and where you can write in a higher level language and it will compile down to macro B and expand out all the loops and if statements, because we don't really have very good conditional statements on a lot of machines, and the
Right.
jumps and loop structure, it all sucks. And we're limited by like O-numbered programs, and you can only pass in enough parameters. Like the Bloom macros, you can only do a tolerance check or a position check, but you can't do them concurrently because they both use the T letter. And if it's positive or negative, it changes if it's size or position. But it had to be that way because we just ran out of letters in the alphabet, which is ridiculous that was even a problem. Like on modern machines, we're still using G65 and letters, and there's only so many letters we can use. And we have limited if statements, we have limited jump conditions. The programming is really gimped on, I guess technically it's Turing complete, so we can do it, but it's so annoying trying to write macro programs after you've written in Java, JavaScript, Python, C, any language that's actually useful.
I think the D control on Brothers has improved this a little bit. Like they have actual conditionals now instead of the sort of weird half conditionals that they have in the C. But it is really wild how limited those languages are. I know that the Datron control has fixed this. Like you can define functions and use arguments, and it's a real programming language. Has Heidenhain, do they have those limitations?
It's better. I don't know enough about it to say it's like really, really nice, but yeah, they have much nicer, like you have labels, and you can just specify a number of times to loop through something without writing your own loop structure. And yeah, the labels and jumps are certainly much better. I don't know about the conditionals. I haven't really gone deep into the Heidenhain programming side, and I don't think I'll ever have to, because they don't have probing macros at all. It's just baked into the control. There is no like sub-program call to a macro that you could go look at. It's just, here's a touch probe cycle, and it's all baked into the control, and it's fully aware of all the kinematics. And so it works if you have 5-axis and you're tilted at an arbitrary A, B, C angle, and you're probing. I'm not probing an X, but I'm really hitting the part in what like would in a 0-0 orientation be a Z. It writes to the Z preset. Like it just works. Everything is magic. It works.
That sounds amazing.
It would be ungodly complicated to make this all work with macro B. So
I did dip my toe into writing macros when I was visiting Dylan. I didn't finish, and I really should get back to it, but I wanted to combine like the kinematics, all the steps of the kinematics where you calibrate the gauge tool, you calibrate the laser, and then you calibrate the probe. Then you do a skim cut on a bolt or something and calibrate the probe for length, and then you calibrate for diameter in the gauge ring, and then you go and do the kinematics on the gauge ball. I really wanted to get all that integrated into one macro for him because he's getting a pallet system. And so then you can throw that on a pallet and have the pallet call up as part of your warm-up and run kinematics. I didn't get there. We got, 50% of the way there. So I started to see the I9 language and like Q variables and stuff. But it does look more usable than the Brother macro B stuff for sure. Have you written any other macros?
I have broaching macros.
Oh, okay. Do you have the 16K spindle on your Brother?
Yes, and it is ceramic balls with steel races, so you really shouldn't be broaching. Okay. I do it all the time anyway, and I only do like 1/4-inch keyways and real baby step overs, so I'm not worried about it.
Are you hand coding that when you do it, or?
So the way I have it set up, I have the macro as its own thing, and then in Fusion, I'll do a manual NC pass-through to command the G65 line, and I have it written where you're passing in the center of the circle, I guess. It's for broaching keyways in bores. So I pass in the center of the bore, and then the clock angle of the keyway, and then the distance from the center of the bore to the like edge of the high point of the key, I guess you'd say. Mm-hmm. And I have it all fancy calculated out where if you know the diameter of the bore and the width of your keyway, I can figure out exactly where I should start my step overs to like just barely clip the corners of the insert to the tangent of the bore. And that's all automatically trigged out. and then it keeps honoring your step over until you get to the final dimension, and then it does some skim passes. And another interesting aspect of that, I pull in the wear offset, the radius wear offset out of the tool table for that broach tool, and use it for comping in addition to the like center line to the edge of your broach insert number. I add the wear offset from the tool table. So after I'm done broaching, I can take the probe and measure where my, like the edge of the keyway ended up. And on the bloom cycles,
width of it?
Like the depth, I guess you would say.
Okay.
The bloom cycles, if you add an E value, it's the tool number that it'll comp the wear. Mm-hmm. So if I'm like 2 thou short, it'll comp minus 2 thou into the wear offset. And then the next part I broach, it'll be bang on. And you can kind of chase out the tool wear and tool deflection that way automatically. I've done batches of hundreds of parts to broach, and it's really sensitive. The broach insert starts wearing, it starts deflecting more. All of a sudden you've got 5 thou short on your broaching depth. And you can try to measure that manually and comp it in. I guess you'd be typing it into your G65 call for more depth, but I just comp it into the wear offset and it works.
You, so like you'll measure, you'll cut with the broach, measure, you won't recut that part. You'll just let it affect the next part.
If it's still within tolerance, yeah, we just let it go.
Wow. Okay, so here's a bad idea. Some, there are some tools like right angle heads that'll like, you can tool change them, but they dock into like an additional block on the spindle or something. It seems like that would be great for broaching, because then you wouldn't load your bearings at all.
I think they don't really take any axial load. They're just for clocking.
I mean, but you could make it take axial load. I guess then you run the risk of like...
Two of them on either end of the spindle.
Yeah. Okay, yeah, so definitely complicated.
Some older Kerns I've seen, they have the spindle and then they have like a secondary thing. I think it was intended for guilloche, but I suppose you could use it for broaching. It's just like another attachment on the Z housing that's not the spindle. At this point, you'll just buy a broaching machine or a wire EDM.
Or a wire EDM. But it sounds like you're taking such light passes, you're just not worried about it.
I'm not worried about it. And some people will tell you have to like reorient the spindle every time to roll the balls around and get them to land in a different spot in the races. That's probably not a terrible idea either, but I'm not really worried about Brunelling the races. So, yeah.
Be easy enough to have that into your macro though.
Yeah. And the Speedio clocks that spindle around so fast.
Yeah. Okay. The only other set of macros I've written was for Wes at Dozer Machine, and I was just visiting his shop, and he asked if I could help him write a tool loading macro so that he could load like 5 or 6 tools at once. The Bloom tool set macros will tool set a bunch of tools, and with a turret style like on a Brother, you don't really need a macro to help with that. But on his what is it called? Dual arm changer. It was helpful to just call once and then throw the tools in. So we wrote that macro. In terms of more bad ideas there, he recently asked if I could help him make it so that macro would zero out the wear on the tools every time you loaded or unloaded a tool. I actually like that. It's how I run my machines because I'm doing such high mix stuff. And the way we number tools in the Speedio, I think for us, we just really stick to like 1 through 21. That's how many tools I have. Do you have 21 or 28?
I have 21.
Okay. So tool 7 is never, the same thing. And so I don't want to forget to remove a wear value. So generally speaking, I just have it zero them out. But I think that's sometimes a controversial topic as to whether you want to do that or not. And I think a lot depends on whether you're production shop or how you like to run your machines. How do you deal with wear? Do you just zero it out by hand, by in your brain?
When I write the tool length, it zeroes the wear. And then for radius wear, it is what it is. If I'm going to be using tool wear on that tool, I'll manually go in and make it a positive value. And then we'll take a cut, measure, and then comp it to what it should actually be. But yes, that does risk me not remembering to do that and cutting with a huge wear negative value from a previous tool. So that is a risk.
Yeah, there's unfortunately no great sort of universal way to deal with that.
Well, it's largely tied to the way Brother handles tools, and it's like so much extra convoluted work to use like all the tool numbers that don't match pot numbers and trying to store offsets offline and stuff. It's just so much extra hassle. The way Heidenhain does it, every single one of my tools is always that tool, and they're all by name, and I store offsets offline. There's never any wear offset problems. If every control could be that way, I would be so happy.
Huh. Yeah, I guess that's a good point. Interesting. And there's no limit, really, no practical limit to the number of tools you can have on a Heidenhain.
Yeah, I have thousands of them.
I can't remember what it is now, but on the C control, you can use tool numbers 1 through 99, and then you have to go to 199. And there's some weird reason.
The hundreds are tool groups for doing like tool redundancy.
Sister tools. Okay.
Yeah, I've never done it personally, so don't sue me here. But I believe you'd create a tool group and you put tools into it, and then instead of calling a tool number, you call the tool group number, and it'll grab whichever tool has life left in it and use its length and diameter offsets. And once it runs out of life, it'll switch to the next one. When you call that group, it pulls out a physically different tool.
Got it. Okay.
Does seem pretty slick. That's actually a lot cleaner than a lot of panic machines handle sister tooling.
Makes sense. I mean, Brothers are originally production style machines. That makes sense why they would do that. I wish they'd come up with a nicer way to do it, but whatever.
The way, and actually, I think this is largely Hermele's own scripts and custom screens, but the way the tool table is handled and whether tools are loaded or not, and putting them into the magazine, taking them out, making them a hand load tool, it's all so seamless and like intuitive. Everybody should just start taking notes. Do it like that. When my Yamazin guy was over, he was telling me about the new 100 tool Speedios and how you can't load tools through the back, which is like a huge oversight in my opinion. You can only like stop the machine, open the door, and load through the front.
No.
For 100 tools. Yeah, there's no door on the back to load the side magazines.
That is a terrible idea.
First of all, you guys need to add a door on the back. And second, like go take notes on how Heidenhain handles this. Where we just have a gigantic spreadsheet of 1,000 tools if you want, or more. And you just say, all right, put this one in the magazine, and you put it in, done.
So this one I think is a little controversial, but on the Sile, I don't do this on the Brother, but I've considered it. On the Sile, the macros that I wrote to load and unload tools from the umbrella also zero out. Well, they technically don't zero it out, but they zero out the tool length offset. So anytime I unload a tool from the machine, it resets the length. And then if I load a tool, it'll automatically go and touch it off. And I know that Heidenhain will touch it off like on first use, which I really like. At least on Hermle, they do that. I don't know if all Heidenhains do it.
Yeah, that's custom PLC data. Like they added extra fields to the tool table. And one of them is like if you want to measure a tool and if it's already been measured. So it is pretty slicky if you say measure length and it hasn't already been measured. If you pull a tool out of the magazine, it flags it not measured, and you put it in. And as soon as it touches the spindle and it's marked to measure and it's not already measured, it goes into the laser and measures it. So yes. I can throw a bunch of tools into the magazine that aren't even measured and just walk away from the machine. And if it's going to use it, it pulls it out, measures it, and then uses it.
So I basically do something similar on my Sile, but I've had several people say that that's controversial. They're like, no, if my tool 30 is always tool 30. I measure it once, I never change it. I found that my tool setters, and we'll come back to this, but even my $50 Amazon tool setter is accurate to within a few tenths, which is more than accurate enough that I honestly would rather have it be tool set when I put it back in the machine, even if I didn't touch the tool, just for the sake of sort of not having to think about whether tool 7 is the same as the last time I measured tool 7.
Another benefit of just like touching off all of your tools at the same time is it doesn't necessarily matter exactly what tool length everything is, just that they're all relative to each other. And so you eliminate kind of intrinsically any thermal deviations by just touching everything off at once together. And then every tool blends in perfectly.
So there's a bad idea that might be good. like putting it in your program, like in your post or whatever, to have it touch off every tool at the start of the run. Whether on first call or just doing it as a block beforehand. But you could make that block skippable, because if you were doing like 20 parts, you probably don't want to touch every tool off at the start of every run. Although on a Speedio, that might cost you like 40 seconds or something.
Yeah, my macros are structured that you can call the tool touch with a G65, and that's actually the way it works from the master program. It calls the like touching off sub program with a passed in value for which tool number. You can make your post just put out a block of sub calls with each tool number that it's going to use.
How would you feel? I actually forget, do your macros, like if there's a length in there, do they like wrap it to the tool setter?
No, I assume the length that's currently in there is arbitrary and from whatever previous tool and not to be trusted. So we're feeding there's a seek feed rate from the Z home all the way down. And then once it hits the first time, it backs off to just before the trigger point and feeds in at the measure feed rate.
Right.
And the Bloom Z Nano has massive stroke in the Z, so you can overrun the trigger point quite a bit. And the Speedio just has ridiculous Z acceleration. So I can feed in there really, really fast and not worry about crashing the setter. And then the brake check I have.
What about for really small tools? What's your seek speed?
I think it's at 4,000 millimeters right now. And you can run it way faster, but I have it slowed down for the sake of small tools.
Slowed down to 4,000. What is that in moon units?
Now, probably 160 inches.
Inches per second. Come on, Google.
Yeah, 160.
Yep. That's so fast. What's the smallest tool you've tool set at that seek speed?
Well, I do 30-second and smaller, like a 0.5 millimeter end mill, but I take the feed override and crank it way down. I let the seek feed rate be affected by feed override, but then the measure feed rate, it triggers the code to ignore overrides, so it measures accurately.
That makes sense. So you'll manually slow it down for small tools.
Yeah, I thought about, like, if I have settings in like a table of settings for setting the number of inserts and the clock, and I could make a parameter for like flagging a tool as fragile or something, but I just put the tool in the magazine by hand. I'm standing there. I can just turn the knob down. I think that was the simplest solution to fragile tools.
So I guess that's a bad idea. That turns out to be good, is just ramping your seek speed way up if your tool setter can handle it. Saves you a good bit of time. Obviously, with tool break, you kind of have to trust the offset. So you should be able to seek.
Check, I am rapiding to like 1 millimeter over the setter.
Right.
This is a parameter, actually, because if you have a tool pull out, you don't want to be going ham with 1 millimeter clearances. So I think I have to actually hit 5 millimeters where I'll wrap it over and then feed down at the seek speed, and then till we're like right over the electric trigger point of the probe, and then we'll measure. And I have it set up very dangerously right now too. You can do it in safe or dangerous mode. I assume that you're at a clearance height when you call the brake check, and that you will clear everything on your part.
Oh, wow.
So then I evaluate, am I higher than my safety height of the top of the tool setter or not? If I'm already higher than the tool setter, we're rapiding straight XY. And if we're not higher, like my part is lower than tool setter, we'll only come up just high enough to clear the tool setter and wrap it over XY.
I feel like
danger mode. If you want, you can just make it fully retract Z and come over.
I feel like in the Speedio, that is absolutely unnecessary danger mode. I would bet you can't even measure the difference in time meaningfully between a full retract and danger mode. But I suppose to each his own. If absolute performance is what drives you, then go for it. That would be too much for me, though.
Yeah, well, and especially if you're going to be running multiple, like op 1 and op 2 with different work offsets, you're probably going to be doing it where it's reordering tools, and you should already be setting your clearance height such that it can go between parts and not crash anything.
Right.
But yeah, just be careful. There's nothing in the way between your part and the tool setter.
Um, or I guess don't forget to put it into safe mode if there is. Um, okay, well, I think we've beat tool setters to death. Let's talk about probing. You use 2 probes in your machine. Talk about that.
Strictly for having multiple styluses. Usually, I have like the 3 millimeter ruby on a long carbide shank as like the daily driver that does almost all of my probing, and then the other one is like a floater. Usually, it's sitting on a 1 millimeter ruby for getting into small places, but I have like a super long reach 6 millimeter ruby. I have a 25 millimeter disc to reach up under things or into O-ring grooves or whatever I want. It's kind of the utility play. Usually it's sitting on a 1 millimeter ruby though.
You probe into an O-ring groove to like comp in like a diameter or something.
Yeah, so I had a kind of the whole reason that the 2 probes even exist. It was a necessity breeds innovation, you'd say. I had the 2 probes sitting there. I had the second one just as a redundancy play because, I'm just like so crippled on productivity if I have to start not using probes. It was just sitting there in case I ever needed it. And I knew you could run 2 probes. And the one day I just sat down and started digging through whatever random Bloom documentation I had, which wasn't much. I ended up having to basically reverse engineer everything, just brute forcing my way into figuring out how to do it. Well, we got 2 probes working, and I was trying to measure the diameter. I was like using a key seat cutter to cut a radial O-ring groove, and I wanted to reach up into that. Like I had really no way of measuring it. You would need a weird hook jaw caliper or something to reach up in there and measure the diameter. And I got a disc stylus for the probe and went for it.
Will you ever use that disc stylus to go like up down to use it as like a, I don't know, 3-dimensional probe?
You could theoretically. You need a different Bloom probe. The TC52 is Z- only. They make, I think, a TC62 or something that can do Z+ hits. And you'd be writing all your own macros for this too. Because the out of the box, the Bloom Brother B3 that I have, at least, is the other problem is like someone says, oh, you can't do this. And then someone else has a different macro pack from Bloom, different version, different type. Actually, you can. Like, it's so convoluted and nobody knows what they have and what is even possible. But I believe you'd be writing your own macros to do Z hits.
If I remember correctly, you had to like rewire the probe into the machine to get both probes to work, right?
Yes.
Sure.
So the way the Bloom box works is there's a 24-volt DC signal to different terminals, and they call it TC and then duo. The TC is like the normal terminal, and when TC gets 24 volts, it flashes the code through the IR signal to the probe that's programmed as TC mode. Mm-hmm. And if you want to do 2 probes, you have to physically take a wire in the machine from one of your M codes on the Bloom or the Brother board into the duo terminal on the Bloom board. And then when you feed 24-volt DC into the duo, it flashes the different code that only turns on the duo mode probe. So that's the hardware side. And then I had to do a slight hack job on the macros to tell it to look at a different start address for the calibration values, the XY offset and the XY radius. And then I also evaluate which tool is in the spindle and assign different M codes for on and off. So probing, when I'm probing, it's completely agnostic to which probe is in the spindle. It looks at which one's in the spindle based on tool number, assigns the correct on-off M codes, and assigns the right address to look for the calibration values. So it just works. There's a million ways you could have handled that.
Wow, that's a lot of work to get 2 probes running.
When in hindsight, it's not that complicated now that I know how everything works, but I was going into it blind with like none of the actual install manuals from Bloom and not knowing how all this worked. So I was sitting there kind of reverse engineering how the existing thing worked. Mm-hmm. And then brute forcing. I like, okay, duo, this sounds like what I want. Duo mode, I think, is what I want. And yes, it was. But
I can say that it's definitely a bad idea that turned out to be good in your case to start changing settings and rewiring your probe on the fly. But I think as a side effect of that, you found out that bloom probes have a Renishaw mode built in, right?
Yes. So when you're programming through the modes and there's a magnet and there's little Hall effect sensors in the bloom probe. And when you insert the batteries and you put the magnet over the set and mode switches, that's how you program the thing. The Renishaw probes, you just do it by manually sugaring the stylus with your hand. And they have an app for doing it. But when you program the bloom probes, there's the TC mode, the duo mode, and then there's like mode R. And they don't elaborate at all at what this is. And I don't know who told me this or where I read it. It was years ago. And mode R is Renishaw compatibility mode. And you can program a Bloom TC52 probe to mode R and put it in a machine with a Renishaw like OSI, and it will work.
And I found that out because I was trying to troll you. I don't remember why. I think you mentioned that you wanted to have 2 probes in the Hermla or something. And I was like, well, just go grab your extra bloom probe out of the Speedio and throw it in the Hermla. I'm sure it'll work. I think 5 minutes later, you sent me a video of probing with the bloom probe in your Hermla.
Yeah, I had known about this and it like completely skipped my mind. I was getting ready to order a OMP 400 on eBay, which I ended up doing anyway. But I was like, wait a minute, I do have a second probe for the Hermla.
My favorite part about that video was that I think the probe was held in a drill chuck, which was then held in another tool holder.
Yes, I haven't found any HSK one-piece drill chucks that I like that don't cost $800 each. So I got 3/4 straight shank drill chucks from Haas and put them in 3/4 weld-in holders for HSK. And those are my HSK drill chucks. And then I didn't have like a bloom probe holder for HSK, obviously. So the back end of a bloom probe is just like a 16 millimeter shank or something. So I just grabbed it in a drill chuck just for like quick and dirty testing that it would work.
Then you ended up making your own holder, right?
I bought the bloom holders are actually Comet boring holders in disguise. So I found on eBay a Comet BTH or whatever they call it. And Bloom calls it BTH. Comet calls it like KBH or something. Got the right size Comet boring holder. So I have a native Bloom probe holder now. But the Renishaw HSK 63 probe holders, I could not find anything on eBay for cheap, and they want like $800 for it from Renishaw. So I made a Renishaw holder.
Here's a bad idea that I don't understand why we don't use. I'm sure it's bad and I just don't understand it, but I hate the 4-screw centering system that we use on probes. Drives me nuts.
Well, at least it's not 3. Heidenhain probes have 3. That's even worse.
So do the probes you get from Tormach, actually. Yeah, 3 is bad. I don't understand why we don't use an eccentric, like rotating setup. Maybe even one with like a little worm gear on it or something.
This seems even more difficult to adjust.
Really? I don't know, because it's like monotonic in that case, right? Like you just turn.
Are you just going to rotate through the eccentric until you find the spot where it's 0?
Yes. Yeah. But it's monotonic. So like you could use like a binary search, right? Like you could do, I don't know, whatever. Imagine it was 3 turns for full rotation of the probe. So you could do 1.5 turns, see if it got better or worse. And then do, half, 3/4 of a turn.
Sure. Yeah. There's only one solution and it's always going to be linear. You're either going to be getting worse or better. You're either getting closer or further away from the correct orientation.
Versus like the 4-screw method where like you get it kind of close and then you're just fighting like tension in the system as you tighten everything. I don't know. I mean, the truth is that modern probes can account for a little bit of run out. So it, like, as long as the probe is reorienting, it kind of doesn't matter. But I don't know. An eccentric adjustment system for a probe seems like a good idea to me. It must be dumb because otherwise I feel like we would use it already. I don't know. Maybe it's not stable or something.
Cost.
Yeah. Yeah. Okay. So in terms of like ghetto probing systems, because Bloom and Renishaw are pretty legit, I've done a couple of ghetto probe systems. I started out with a Drutronics wired probe. That actually worked pretty well. It is aluminum bodied probe, which is kind of questionable from like a thermal stability point of view, but there's really no reason that your probe should be changing temperature in like a meaningful amount. I guess depending on your shop, winter to summer or something, but you could recalibrate around that. So I thought that was okay. They do sell a wireless probing system, but the price goes up to, I don't know, the wired one was like $200. I think the wireless one's like $1,500 or something, which is still a good price for a probe. I ended up moving on from the Drutronics one after I unfortunately crashed it. I bought a Tormach one and I put the zoom speed probing kit on it. I think you're $700 in for the zoom speed probing kit, with the $700 with the probe, which is pretty affordable. And the Tormach probe works fine. It's just a simple like kinematic coupling mechanism. It does have a 3-screw centering, which is annoying as heck. But the downside to the zoom speed kit is that it was designed to not need M codes to turn it on or off. So it's just always on. And the battery in it only lasts like, I don't know, call it 2 days or something. So I like the kit. It's okay, but that 2-day battery life means that I basically leave it out of the machine and only put it in when I need it. And I like to leave it like in a little charging cradle. So I'd say ultimately for me, that one was a bad idea that didn't turn out to be good. I think I would have been better off with like the wireless Drutronics kit or something.
I think the meta right now is like the silver CNC Renishaw clones.
Yeah. We'll come back to silver CNC in a second. And then I didn't want to pay like $1,500 for the Pioneer Chinese tool setter that came with my Sile. So I just bought cheap Amazon tool setters. And they served me pretty well for about 3 years. Surprisingly accurate, within a few tenths, repeatability. The problem with them is they're not like coolant sealed very well, and it's very hard to predict when that's going to become a problem. So I end up not trusting the tool setter to like work properly. And I go into like the IO screen and I tap the tool setter every time I turn on the machine to make sure it's triggering. And that has for the most part worked fine for me. But a couple of weeks ago, I went and did that. I went and tapped it. I saw that it was triggering. And then I went and tool set a pretty expensive custom ground dovetail cutter that I use for making my soft jaws. And it just didn't trigger and smashed the setter and broke the tool. Pissed me off pretty good. Now, I had a spare $50 tool setter sitting in the drawer because I would like take them apart, clean them, and swap them back in. So I put that one in, but I ended up ordering the silver CNC tool setter from Possum Solutions. He brought a few in. Because for $300, having one that's actually properly sealed that I could just leave in the machine and not think about seems like a good investment. So we'll see how that one works.
Yeah, it's pretty much what you get in this industry for paying more money. Like the Bloom Z Nano doesn't do anything really fancy. It's literally just a switch. That's all it does. It's an on-off switch. That's what every tool setter is. But you're getting the absolutely bulletproof. It will work.
Right. Yeah.
And I think it's wired normally closed. So if the wire was cut, it would trigger. Mm-hmm. I think that's the way all probing systems at least should be, and all mine are. Like if I lose contact with the probe, like visually, or the IR receiver just craps itself, it will trigger the error input and the like G31 skip trigger signal. Mm-hmm. Mm-hmm. So
yeah, I don't have the error input wired into the Sile. I'm not even sure there's a space for it. So yeah, but so I think tool setters is one place where I've learned that spending the money there is worth it. Before I ordered the one from Possum Solutions, I was tempted to buy a used Renishaw TS27, the wired one. I think wireless tool setters are silly. I don't understand them at all. Wireless probes make sense to
In
me.
a vertical machining center, yeah, it's really nothing to pull some wires around. And I have air wired up to my table for running the Pearson vacuum system and the Pro pallet. And I have air to the tool setter to blow off the stylus that the M code triggers to blow the air whenever the tool setter is in use.
Mm-hmm.
So I already had wires dangled anyway. So what's another one for the wired Z Nano? They do make a wireless one though.
They do? They make a wireless Z Nano?
They do.
Okay, interesting. I guess if you have it on a trunnion or something.
It makes sense on the R machines with the pallet change.
Oh, okay. All right. That's fair. That makes sense.
There is a feed through in the middle of the pallet change for wires.
Right.
So it's not a big deal to have a wired one either, but that's where I've seen it used.
Okay. All right. Okay. Any other bad ideas for probing or tool setting?
Be careful, know what you're doing. Don't just blindly change things, but don't be completely walled off to thinking like this is a black box that I can't go look at. I can't go mess with it. I can't change anything to be how I want it. Like it's your machine and take responsibility for the things you break, but you can go tweak whatever you want. Nobody is stopping you. This is like an arbitrary line in the sand that I freely jump over constantly. But a lot of people just seem to be completely scared to tinker with anything. And I think it's largely driven by they don't understand it, which is fair, but you're not going to start understanding it until you start playing with it.
One place where I'd like to actually modify both my Sile and my Brother macros is to adopt the calibration method that the Hermla uses, where like right now, both machines will calibrate the probe off a gauge, essentially, like a known reference height off the table. But in the Hermla, the method is to just like calibrate the length of a tool off a tool setter, then mill flat a small bolt or chunk of aluminum or something. And then now you know like perfectly relative to that tool, which has just been calibrated off your tool setter, which hopefully itself has been calibrated off a gauge tool. You know that's 0, so you can go to that spot and calibrate the touch probe off that. And I like that for a number of reasons, but the biggest one is that on the Speedio, there's a chance, especially if you've crashed in Z, or like when I first bought my machine, they put a new spindle in it because I needed a field install of a Big Plus spindle. And there's a chance that the Z encoder height is just wrong. And if the Z encoder height is not correct, then the gauge tool method will not give you an accurate probe length. And that bit me one afternoon. I don't remember. I think it was like right after we got the machine because the techs forgot to recalibrate the Z encoder after they installed the spindle. I think that's what happened. Otherwise, it was after a crash. But either way, like I cut apart and then measured it, and it was off by like 10 thou or something, way more than could be accounted for by any kind of other error. And so I ended up tracing it all the way back, and I was like, okay, I will like cut this surface and then probe and then like look at the differences, and I could see the 10 thou is showing up right there. And so I think,
do we want to go down the rabbit hole right now? Because I can tell you like all of the ins and outs of all of this.
yeah, go for it.
Yeah, so I do prefer the Brother method versus I think it's kind of there's a reason that Hermle / Heidenhain does it that way, and it makes sense. But on the Brother, your tool lengths don't necessarily have to mean anything. They just have to be relative to each other.
Mm-hmm.
And on the Speedios, G54 is like spindle to the table, which you couldn't actually do. There's not enough Z stroke, but that's where they set the encoder from the factory. And like you said, if they change it, it's no longer like necessarily true, or just thermals or overtime, any number of things. So I never trust that that's necessarily true. But the way the Bloom macros work for the spindle probe is the Z calibration value is only an adder on the tool length from the tool table. So if you take your probe and touch it off on your tool setter and then come and calibrate Z on a surface that you've determined its location through any means, whether you've milled it at 0 with a known tool or you took your gauge standard with a gauge block and made the gauge block just barely slip under it and set the surface, however you've determined the surface location, You take your probe over, you calibrate in Z, and it's going to be like 2 thou or something that goes in the Z calibration value, and you're good forever until you change measure feed rate. You can change stylus. You just go remeasure it on your tool setter. Done. The only thing they would ever need to recalibrate Z is if you change measure feed rate, and you should be good forever. And if you change stylus, you have a thermal variation, whatever you want, you just remeasure the probe on your tool setter, and everything is perfect.
Whoa. Wait, hold on. Really?
So there's caveats to this. If you have the TC52 LF low force, the spindle probe will trigger before you've deflected the tool setter enough. So like, use your brain, sanity check that you're getting good numbers off of this. But I do it all the time. The Z trigger force on my TC52 is much greater than the Z trigger force of the Z Nano tool setter. So it measures very accurate heights.
And so normally this would be considered a bad practice because there's two springs accounting, right? Like when you probe,
this only is valid that the trigger force on the spindle probe is like an order of magnitude higher than the trigger force on the Z Nano. So it does work reliably.
But also
this would be a caveat.
That secondary calibration off the known thing of like, let's say it comes out to a few tenths also accounts for that differential.
As long as it's consistent, but if we start deflecting two springs like together, it just,
right.
I would say it's not reliable to tenths, but
which is
like
why,
micron accurate.
Which is why the LF version, you can't get away with it. Okay.
And I can only speak to the TC52 and the Z Nano, where this certainly works, but it's something to think about, I guess. And if you had a laser tool setter like I do, I kind of wish there was a way where I could just laser the stylus in the machine, and the calibration value is just the difference between the physical tip of the probe and the electric trigger, plus like the reaction time of the machine at your feed rate, whatever the number needs to be.
That would be fairly constant, and then you could swap out. Wow, this is, I didn't know this. I'm definitely classifying this as an idea so bad that it's good, because the two springs thing is like a theoretical hard line of like, this does not make sense. Although you're right, if one of them is an order of magnitude weaker than the other, then you can make a reasonable approximation. But the secondary calibration, which soaks up some more of that difference. And I just ran through the calibration process and noted that like the calibration didn't get saved into the tool table, which is what I was expecting it to be. But if I had put that value in the tool table, now it would have just been a correction. This is amazing.
A lot of machines work differently, and when you calibrate the Z, it's writing a tool length to the tool table.
Right.
The Bloom on Brother stores a small Z value of Z calibration to the like macro variables, where it stores calibration right next to the XY offset, and it's an adder to the tool length. So if you go into your tool table and just make the probe length an inch longer, like it'll start probing an inch off.
As soon as we're done recording, I'm going to go turn on the machine and rerun the probe calibration to take account for this. Because the ability to just change out the stylus quickly and then run it over to the tool setter is so valuable that if it's really as accurate as you claim, which I'll take your word for it until proven otherwise, that's amazing. That's a huge win for brothers, and everybody should set up their tool setters that way.
Right. The other gain here is I can just cancel all thermal deviations whenever I want. You just go measure the spindle probe on the tool setter with all your other tools you're using, and boom, everything is relative to each other perfectly.
That is awesome. I'm absolutely going to go try that. Definitely a bad idea. That's so bad it's good.
Yeah, I think a lot of people would take issue with touching off the spindle probe on the tool setter.
Oh, yeah,
there are certainly areas where that's a bad idea, but it can.
I'm sure we'll get all kinds of hate for it in the comments. I've heard, because that's how Haas's macros do that, like right off the bat, right? And on theirs, I think, because the Renishaw touch force is so light. Anyway, yeah. I'm sure we'll get some hate for it. I would have, until this conversation, I would have said, this is not the right way to do it. But you've convinced me it's at least worth a try. Okay.
If you were exploring, it could be a good idea.
Yeah.
In the right scenario, it does work. I do it every day. All of my customers will testify. I make amazing parts, and I've been doing it with that calibration method on the Speedio since day one.
Um, we'll have to see if we can try and get Grimsmo to give it a try. I know he's been fighting thermal comp on the Brother forever.
Well, I think he has a laser anyway too, so it's even easier.
Oh, that's true. He does have a laser. That's right. Yep.
But we don't even have. I think he's probably running the LF versions as well. Actually, I think he has a radio probe. It's a Bloom radio.
I thought they got rid of the radio and replaced it with a optical one. I'm pretty sure he did.
Which is interesting. Normally people go the other way.
I think the radio one was just, it wasn't working. It was like being really inconsistent. They may have just replaced it with another radio one. I wouldn't swear to that, but I know he got it replaced. Yeah.
I don't follow, but it is quite interesting with his little grinding setup and the laser and the Speedio.
Yeah. All right. I think we've beaten probing to death. Let's move on to some other topics.
This could almost be a whole nother podcast episode on its own here.
You mean probing or the other topics?
Well, everything beyond probing. We just spent an hour going through probing.
Wow. That's okay. We can have a long podcast. I get good feedback on long podcasts. Let's just go down the list. So this is one of my favorite ones. You and I talked about this a bit. I have an engine hoist in the shop. I've had to load heavy things into the machine a few times. Sometimes I can use the engine hoist, like with my 4th axis. I used it to get it in there, but it's always a little awkward because the legs, bump into the machine, whatever. It wouldn't work on the Speedio. So I'm very tempted to just like turn the thing around backwards on its mounts and then put a crap ton of weight on the engine hoist. Should be sufficient from a physics standpoint. No problem with that. As long as you put more weight on the back than you're hanging off the front, counting for.
And you might have to weld some gussets in there so the thing doesn't just rip its welds apart.
Yeah.
But yeah, you were telling me about this, and then we're like, okay, how are we going to load it up with weight? And I was thinking about like, what would we use? And I thought, water. You can just put whatever container you want, fill it up with a hose. Now you have a bunch of ballast, and then when you're done, you dump it down the drain, and you're good to go.
Right. I'm of two minds about this because, like, on one hand, we have scrap bins full of metal, right? And if this thing is going to sit as a reverse crane forever, like, why use water? But on the other hand, like, buying 150 pounds or 300 or 400 pounds of steel, it's not like free.
And you have 400 pounds of steel sitting here always.
Right. Right. So water feels like a not bad idea. The only problem is you run the risk of somehow the water container getting punctured. But I have trouble imagining, I mean, don't do it with like water balloons. I have trouble imagining like puncturing it in a way that the water would leave so fast that you wouldn't have time to deal with it. Right. So.
Right. Like, this is the caveat that if you need removable ballast, you're going to like take your little engine hoist and fold it up in the corner when you're not using it.
Right.
I have a forklift. And if you're going to permanently install it, like, just buy scrap steel, like buy wheel weights,
right?
And like for a tractor, that's just cheap steel weight, and keep it on your engine hoist. But removable ballast, I'm thinking water. Can you use your forklift to get parts in your machine? I have a table in front of the Speedio, but the Speedio max table load is, I don't ever put anything that heavy in there. I do forklift stuff into the Hermley. Okay. All right. So I think we are deciding water as a counterweight for a shop crane is a bad idea that might be good, depending on what you need. Even for like those sky crane things and stuff, you could use water. Yeah, I see people either put those straight into the concrete next to their machine, which I'm tempted to do on the Hermley, because it was kind of a pain in the ass getting the forklift to not crash into any of the sheet metal, and then getting myself in there to unhook the chains and whatnot. Right. I kind of want a sky crane. And then people put them on a cart, and they put a bunch of weight in the bottom of the cart. And that seems pretty slick too. Right. You can use water for that. It's like the engine hoist, but slightly smaller sky crane cart. So sky crane's on your Christmas list is what I'm hearing. Maybe. Okay. Noted. The other, I might just do a gantry crane. That's even better yet. As I forget, does the Hermla open, do the doors open with like enough that you can crane stuff in? The doors open, and then the entire roof can telescope open, and it's like completely wide open. With like a separate actuation or whatever. Okay. Yeah, it's like you unhook it, and then the entire top just like accordions backwards. I was visiting Zach Smith, and he needed to put his 4th axis back into his Kern. Evo, after he rebuilt the X-axis on the Kern in front of me, which is insane.
and he had a Harbor Freight electric hoist that he had like, I want to say ratchet strapped to like they're not I-beams. I don't know like the trusses on the ceiling. But that thing, this definitely is so bad it's good. That thing doesn't have like a smooth like crane actuation. It's like you press the button and it like bounces up and down and like locks into a ratchet wheel. So like it's like the fourth axis is going like, man, did it make me nervous. I mean, he got it in, he gets it in and out of the machine. Good for him. But man, that scared the crap out of me. I'd probably draw the line there at like the cheapest hoist you can to hold up this like $50,000 5-axis trunnion for my Kern or whatever.
Yeah. A tangentially related idea that I really like, I see a lot of people do, is they put a chain hoist in the like top right corner of their machine's sheet metal enclosure.
Mm-hmm.
And if they have a fourth or fifth axis, they keep it electrically hooked up constantly. And you just unbolt it from the table and hoist it up into the corner. It just hangs out in the machine, hanging from the sheet metal in the corner. You have your full table to play with. And then you just move the table back over there, engine hoist it down, bolt it up, and you're good to go. You never electrically unhook it, and you don't have to deal with like storing it anywhere. And, like obviously the thing is all waterproof and meant to be in the machine constantly anyway, so it's not a big deal. And they're heavy, but not that heavy that you can't hang a few hundred pounds from the sheet metal in your machine. And so that seems to work really slick.
I think Pearson has a video on like how he did that with like specific McMaster part numbers. And I saw Jamie from JSpec recently do that with his super ghetto fourth axis. Kudos to him for making an indexer just to get his jobs done. I think some people wouldn't, I mean, I would normally like count out an indexer, but if you're looking to bootstrap, and when I say indexer, I mean, he bought like a cheap fourth axis that was non-functional. He probably found it on the trash pile somewhere, knowing Jamie. And then he hooked up a motor to it with like a Raspberry Pi controller so he could just manually index it in like 10-degree increments or whatever he wanted. And then he went and made like this impeller looking thing, beautiful part. I mean, you know, that's like a great way to bootstrap stuff. Obviously having it all in the control and everything is like much better, but man, that's a bad idea. That's so bad. It's good. Good for him. He also made a winch to like get it off the table. But then I found out that his machine doesn't have a roof on the enclosure. That's the first time I've seen a modern machine, you know, since like 90s or something that didn't have a roof. So he can actually like just hoist the thing straight up out of the machine, which is cool. The machines that can't do that are like Kurt from Confounded Machine has a Sile X5. And then like a Speedio S300, if you got one of those of the fourth, there's not enough like space in there to get around the turret to like winch the thing up. I think if I was doing that, I would want my fourth to sit on like a Lang plate or something though, just so that I didn't have to re-indicate it or anything every time I took it in and out.
Yeah, I think Pearson sells, it mounts the rotary like outside of your travels and hangs it off the edge of the table a little bit so you have more machine travel usable, and it's like a quick mount so you can just slap it on there and go.
We have his smart plate. I don't remember any kind of quick mount feature. I'll have to check.
He might have just put a Pearson Pro Pallet system on it.
I think that's
that what as like a quick mount.
Yeah, I think that is what he did. And then that buys like a little bit of extra sort of Z height for the fourth axis, which if you can afford it, if your way of using it is.
Yeah, that's a plus and a minus. You can swing a bigger part without hitting your table, but then you also need that much more Z positive on your machine, which on the Speedios is a problem.
Right. Okay. So I think we agree that janky hoists are a good idea and water is a good way to make cheap counterweights. Just be careful not to use water balloons.
Somebody's going to try this and then they'll tell us if it's actually a good or bad idea.
All right. Well, we hold no liability for when they try it.
Send your hate mail to me. It was me.
There you go. All right. Let's move over to tool holders. You recently posted a pretty braggy video on Instagram. I appreciated it. I think it took you 7 or 8 hours to walk in front of all the tool carts you have. That's There was like 700 or 800 of them there, just full of tool holders.
Yeah, I have at least 100 BT30s and at least 100 HSK 63s, probably significantly more at this point. And largely, it is the pre-drill and form tap for all the common inch and metric sizes that just live in holders. They're drawn up with presets for speeds and feeds and fusion. And normally they're even touched off and ready to go. And they sit in the cart in their designated positions as pairs with the pre-drill and the tap. And they never get broken down. And this is insane time savings. It's like so obvious to do this, and I see very few people doing it. And I use these tools every week. Any one of these given tools is probably getting used every week. It's insane that I would break them down and put them back together constantly. And well, in the era of RegoFix tool holders that cost $400 a piece, it makes sense. But in the era of Haas tool holders that cost $30 a piece, all of a sudden I have more money in the drill than I do the holder itself.
Most people aren't putting drills and taps in RegoFix. I don't know that I've ever seen that. There's probably some drills out there in Rego, but taps definitely not. Let's do the math on it real quick. So I don't know. Let's assume a shop rate of $150 an hour. That's pretty reasonable. 5 minutes to set up a tool. Does that sound fair?
We'll say 2. Let's say you're really hustling, or we'll give it the benefit of the doubt because it's still going to make sense.
2 minutes. Okay, so 2 minutes to set up a tool. I don't know. Let's say you set up 600 drills a year. That seems low to me, but let's just come up with that number. And so that's 1,200 minutes divided by 60 minutes to an hour. That's 20 hours times $150 an hour. That's $3,000. So
I can buy all the holders for a lot less than that.
Right. Yeah. So even if you spend $3,000 on all those holders, which, well, at 100 holders, that's $30 a piece. So that's right in the ballpark there. But even if you spent 3 or 4, call it $4,000, just to be generous, you'd make your money back in a year just in the time saved to do a 2-minute setup on a drill 600 times. And then every year after that,
you're going to double your time spent because you have to do a drill and a tap together. It's like,
oh, right. Okay. Right. So
right there, we just made extra time. And I doubt many people are putting tools together reliably in 2 minutes. I can do it. I have my collets and taps all very organized. This is later in the script here on Grid Affinity. But
okay, we'll come to that later. Yeah, so 4 minutes, because drill and tap, times 600 drill tap combinations a year, that seems like a reasonable number to me.
You set up 2 sizes a day. That seems pretty reasonable.
Yeah. Times a shop rate of $150 an hour. That's $6,000 a year in time lost to setting up drills and taps. You can easily afford to buy 100 holders for that. And then the other benefit of the way you did it, and I only thought of this recently, is that you buy all the Haas holders. And I did note one of your stories that like the same part number has some slightly different geometry on it now. So that's a problem. But if we set that aside, and Haas should not be doing that. They need to be incrementing the part number or adding like a -01 or something to it. Not cool of them, absolutely. But
they did email me, actually. They told me the model they have available on their site to download is the bigger radius. And they did that intentionally so that if it clears the bigger radius, you'll be good on simulating with the smaller radius.
Okay, so
I replied to them like, okay, cool, but I don't trust anybody's models. I redraw all the holders myself. So it's still a problem.
Right. Okay. Yeah, I would say like for them, that's not cool. Like they should have 2 different part numbers or whatever.
That's cool. You're dual sourcing. Like they're like, it's probably true. They're selling so many of these. They have to have multiple OEMs. Okay, fair. How about different part numbers, please?
Yeah. But setting that aside, because you buy them all in bulk and all at once or whatever, like from the same source, you don't have to think about which tool holder, like all your models are the same. If we ignore the part number problem. Whereas when I first started out, and still to this day, I try to be as cost efficient as possible. So I'll buy a lot of used stuff. The tooling I bought for the Sile, I got for dirt cheap on eBay. Also probably a bad idea. Just inevitably, you don't know what the condition of the tapers are in or any of that stuff. But it means that none of my holders are exactly the same. Whereas you don't have to think about that, which also saves time. Like if you need to add a new tool, you just throw it into the existing holder. So I think that's another bad idea that circles around to be good, which is that as you start to scale up and think about standardizing, like if you have, like me, a mishmash of holders, like it's worth it to just, I mean, maybe you keep those for special stuff or whatever, but like standardize everything. Like get rid of those and go to a standard set of holders. They're, like you said, they're cheap from Haas, invest in RegoFix or hydraulic or shrink, whatever, but like actively discard your mishmash of holders and standardize on one or two, standard kind of ER holders for that kind of stuff.
And when I built all these tools, like the day I got all the holders and I decided I was going to do this, I can build 20 tools in a row all at once faster than I can individually, mix together doing it 20 times as individuals. You get the wrench out and do it once.
Right.
So it was a real quick process to sequentially just bang out all of them versus if you're going to build all these tools at like random times and different days, you can have on aggregate a lot more time spent piecemealing it versus just doing it all at once and getting it over with.
Do you torque your collets with a torque wrench?
No, I own the torque wrench and all the heads to do it. And I've started trying to convert more to torque wrenches. I have like the 10-year experience calibrated feel on my arm for slices and collet nuts and stuff. But if I'm going to hire people, I can't just tell them, yeah, torque that to the reasonable amount. We need numbers for things. So I've been trying to ascribe different like vice torque values to like in my head what I think they are. And I have the Maratool interchangeable head torque wrench with the ER16, ER32 heads for it. I should be torquing them with numbers and not feel.
Here's a terrible idea. Absolutely horrendously awful idea. Have you ever seen the torque limiting extensions for impact guns?
Okay.
And then you get like a really long socket because you got to have room for the tool. So I don't know, 4-inch long deep socket or something. I'm sure somebody makes one. Put that on the torque limiting extension, put that on an impact gun and use that to tighten your collets. It's the worst idea ever. It's the worst idea.
This is still actually a bad idea. It's not circling into good.
No. Okay. I'm gonna do it and put it on the internet for next April Fools, so people can watch it.
Excellent rage bait. People will definitely eat that up.
Okay, so the consensus is, and I'll agree, the consensus is no to using an impact gun to tighten your collets.
But yes to buying lots of cheap holders and keeping drills and taps.
All right. Form taps, thread mills, and cut taps.
I like form taps.
Okay. Why?
Well, we have the caveat. It's not going to work on anything that's particularly hard or not very ductile like cast iron. But aluminum and mild steel, and even I'll form tap 35 Rockwell 4140. The tap is stronger. The drill is stronger. It lasts way longer. It's just a much more reliable process. There's no chip to bind up, so I can tap as deep as I want. I'll never bind chips. I'll never have chips wrapped up on the tap. There's not huge flutes ground into the tap. There's more meat to it, so it just has more tap to break, so it's stronger. I like it.
Do you get the complete spiral ones, or do you get the ones that have a channel for coolant to exit?
So I use the Amugi multiform with the TICN, titanium carbonitride. They're not particularly good at any one thing, but they will do a really good job in every material. Stainless, mild steel, alloy steel, aluminum, and same with the Amugi multi-drills. They make material-specific drills that can run higher SFM and higher feed rates, but a good all-rounder for if you're going to have a set of drills and taps always set up for any given material. I really like the Amugi multi-drill, multi-tap.
Okay, so these do have some flutes on them though, because there are some
that almost look like a normal tap. You wouldn't immediately identify them as a form tap.
I have bought a few form taps. I've broken a few form taps, unfortunately, because I wasn't drilling the right sized hole. But the ones I got, the very first ones I got were actually for when I was making the Xometry test part. and they had no flute, no relief. It was just a continuous spiral the whole way. And that works fine for through holes, but it does not work for blind holes because the tap forms a seal in the hole.
It's like hydraulically destroying itself.
Yeah. And of course I was tapping blind holes, but so it's important if you're getting form taps, I think, to get, I think most good form taps have at least one relief cut in them to allow coolant to escape.
And to get in as well, equally important. It's kind of carrying the lubricant down the spiral with itself.
Okay, fair enough. Yeah, to let the coolant in. Speaking of, I learned something. So I was at Kennametal's Research and Technology Center the other day for a toolpath meeting, but I grilled their like cutting tool design guys a lot. Asked a whole bunch of stupid questions. We can get into that a whole nother time. But I learned one thing that I thought was really interesting. And this may not be novel to anybody else, but it was novel to me. So almost everybody knows that if you're trying to drill a hole on a not flat surface, maybe with the exception of like the very top of a circle, that you need to like mill a little flat spot, right? Spot face it. But they were asking me, like, when toolpath programs apart, will it spot face the back of the hole? And I was like, not every back of hole can be reached. Why would you spot face the back anyway? And they said, well, if it's not flat, you want to spot face both sides. And then they held up a face mill and showed me like the through hole where they're drilling and tapping the insert screw. They spot face both sides. And it's because a drill exiting on a non-flat back surface will drift. That's like will cause drift. And
you'll chip out your corners too.
Yeah. So spot facing alleviates that. And it's just not something I had thought about before. Obviously you can't always do it. But something cool there. And different drills are differently sensitive to that. So the Kennametal Go drill it's called margin, which is like the support structure on the flute behind the cutting edge. The Go drills don't have margin all the way up the drill. So they are particularly sensitive to like deflection because the margin is really only at the tip. And when it breaks through on a non-planar surface, you basically get it in bending right away.
The majority of a drill's like guiding force is the tip of the drill kind of guiding in its own cone. And then beyond that, you have the margin of the drill in its own kind of pilot, following its own hole a little bit. But yeah, generally drills after the first, say inch or so are just relieved. You don't want the whole drill dragging up the hole.
Right. So just a fun side note there. Try to spot face both sides of the hole if you can, if you need to.
If you can't, what you definitely want to do is dramatically reduce your feed per rev as you break out, so that you don't destroy the corners of your drill.
And Fusion has a breakthrough cycle for that. Yeah, so use that for sure. Okay, so everybody should be buying more holders. I actually had this exact discussion with somebody, a toolpath customer, came to visit the shop. By the way, any toolpath customers or not, anybody listening to the podcast, if you're in Cleveland, Ohio, hit me up on Instagram, come visit our shop. But so we sat down to talk, and it's a really interesting shop because it's in his backyard. He has effectively no overhead because he's got, older machines, but he paid cash for them. And we're talking like under $10,000 for each machine. And his point was like the machine itself isn't that fast. So if he quotes on runtime, he'll get destroyed by somebody with a Speedio or a newer Haas or whatever, right? Because they're just faster. And I said, look, you're viewing it wrong. Like, look, I understand if you want to quote off runtime, then yes, your machine being slower is kind of a fundamental problem. But like, you can quote pretending your machine is 3 times faster than it is to stay competitive. The fact that it actually runs longer is irrelevant. You pay nothing except a little bit of electricity. You don't have overhead. It's in your backyard. You can let the thing run for 3 hours. Like, who cares? So what's really stopping you from setting up a job, getting it on the mill and walking away? He said, well, I don't have a tool setter. And so I have to set up a lot of tools and it just takes time. And I was like, just stop right there. Just go buy a bunch of tool holders, set up all your tools, set them with a gauge length one time. So when you load them in the machine, you can just type the gauge length in. And so that's the exact argument that you have, except for him, it's like orders of magnitude more. If you, and you know, there are folks out there, we have some toolpath customers who don't have electronic tool setters. If you're manually touching off tools, then we're not talking 2 minutes to change a tool. We're talking 10 minutes, right? Like it's a lot, or 5 minutes or something. So in those situations, like, you know, like you said, it's not just one tool, it's two, it's a drill and a tap. And you can extend this to like almost any of your commonly used tools in the shop. There is going to be a limit, like at 10,000 tool holders or something, like a space limit, right? But like, you know, if you have like, say 10 core tools in your machine and another, say 15 tools plus all your common drills and taps that you use regularly, there's no reason you shouldn't have holders for all of those.
You kind of already have to own these holders.
Right.
Like, I have a rant about setting tools manually. I absolutely despise people that jog down into anything, whether it's a 1, 2, 3 block, gauge block, paper. Stop it.
Yeah.
Get some help. You come down too far with your block out of it, and then you come up. You're gently pushing your block or your pin under the tool while jogging up until it slips under.
Right.
Never, ever jogging down into anything. Like people are like, oh, you gotta be really careful. Put it on the 1 thou increment and jog down until it grabs. Like, no, stop it.
Yeah, you're right. You should never put a static load on your bearings like that ever. It's a really bad idea, especially if you're broaching.
Yeah.
Especially if you're broaching. You definitely shouldn't ever do that.
Right. Yeah, don't do this.
I agree. You shouldn't tool set down onto the block. But if we're talking about bad ideas that are good, like it would save you time and it's not fundamentally different than broaching. Well, that's not completely true. It's probably a higher load even at a 10th increment.
I'm not worried about the spindle bearings from binding up on a 1 thou. Like you'll just destroy your drill. It'll shatter the drill before you touch the spindle bearings. But
okay,
you're going to chip out the tip of your tool.
Okay, fair enough. So there you go.
I like a pin actually. I don't use a gauge block. I use a pin because you can really feel as you're getting close, it starts to slip like more and more as you ride up the tangent of the pin. So I'll just jog down until the pin doesn't go under and then click up until the pin goes under in the biggest increment and then come down to like the 10ths and whip the hand wheel quick and then slowly jog up until it just barely slips under.
Right.
Sometimes
I do the same thing.
Too long to do on the laser in the Hermley. Over 300 millimeters, you can't measure.
Oh, interesting. But you can use it?
It can't go in the magazine and it can't go in the laser, but you can hand load it.
Ah, okay. All right. So you've done some deep drilling or something?
Yeah.
And then you have to touch it off manually. Oh, very interesting. Yep. Very interesting. Okay. I guess that goes in another category of bad ideas that are good. Like sometimes manually touching off a tool is okay.
You should be familiar with how to do it because there will be a day either your tool setter is down, you can't be just completely dead in the water, or you have a tool that's too long, or a tool for whatever reason you can't use on the tool setter.
I have done it when, again, $50 Amazon tool setter that I can never trust, which is another reason you should spend more money on a tool setter. But when I've been trying to debug things and I question whether the tool center is working properly or not, I will manually set a tool and then do it on the tool setter and compare them. Okay.
I have a known gauge length tool from Maratool. It just has lasered on the side. It's gauge length. And so to sanity check the tool setter, I'll just measure that tool and see if it finds the right number.
Yeah,
I like doing that.
That works too. I don't know. I definitely have done the manual tool setting comparison thing before, and I can't remember why I didn't just check with the gauge tool. Maybe I was just too dumb. Yeah.
Well, you're also sanity checking your method of manually setting tools. So right. That's good.
Yeah. Okay. So buy lots of tool holders. I think like the math basically just says that like if you can avoid setting up any kind of commonly used tool, do it. It's worth it. And like you said, oftentimes you'll have more money in the tool than the holder these days. So, but also focus on standardizing the holders so that when you're building your tool library, you never have to wonder if you got the right length holder or anything in there.
If you're going to keep it as a permanently assembled tool and it's built in Fusion or whatever your CAM system is, You wouldn't have to standardize because that holder is always my pre-drill for a quarter 20. And we
Right.
just have it drawn up properly in Fusion. But
You wouldn't
even
have to
better would just have
standardize.
everything be the same.
Right.
But if you're going to, standardizing becomes less important if you're going to have permanent tool assemblies.
That's fair. But then you still have to like put the data into Fusion. It makes it much harder to like add a tool to your library.
Well, another thing I did here for building all these tools, I did on the Heidenhain controller, you can export your tool table as a CSV. And then I imported it into Excel and did some Excel magic with like exporting my Fusion library as a CSV and exporting the Heidenhain tool table and kind of copy paste merging this stuff. So I put all of my permanent assemblies into the Heidenhain tool table kind of automatically, saved myself a lot of time having to enter all the names in manually and all the diameters. And
Nice.
then I just re-import the tool table back to the control.
So that was to get the data out of Fusion and into the control.
Yeah.
Okay. Because you don't have, yeah, right.
I was doing tool by name, and it's also, they're all like, Heidenhain uses all radius, there's no diameters. So I didn't want to think about dividing by 2 on everything. I just made the spreadsheet do it.
I asked the Hermly applications guys one time whether you could use the laser to measure the entire body of the tool. Mostly because I wanted a way to verify that the like physical tool matched the sort of inputted geometry. But they said it was technically possible, but I can't remember why it was a bad idea. They thought it was a bad idea.
The way the laser is mounted on the trunnion and the angle it swings up at on these particular machines, you're going to crash into the body of the laser. Now, if you had the laser mounted on a different machine and swung up at a different angle, and you could get into the fork and pass through the fork and not crash anything, you have a lot more options. But when your fork is up, it's like 74 degrees. So you then just crash with the body.
I see. Okay. Right. So you just literally cannot do it. Got it.
Well, you could just make the trunnion swing up at a different angle.
Oh, that's true. Yeah, right. Okay, let's go on to the next topic. This one I would say goes into like the category of sort of general shop improvements. But I know when we wired our shop, I paid $16,000 to have all the electrical done. I did not do it myself. I didn't want to mess with 480 volt stuff. And I paid for a brand new transformer from Eaton. But you used transformers, right?
Yes, I wired my whole shop myself. Menominee Falls Police Department and Fire Department, don't sue me. It's industrial, it's zoned industrial. There's not really any inspections. It's a concrete building. It's all in steel conduit. So like, I'm not worried. Nothing's going to go wrong. And I did it all sized by the NEC conductor rules and stuff. So I'm not a licensed electrician, and don't electrocute yourself if you don't know what you're doing. But it's not rocket science. You can find transformers used on Marketplace or HWR or wherever, and you can wire them up yourself. And you don't need a degree to pull THHN wire through EMT conduit. And you really can't mess it up. If the machine says the phasing is backwards, you switch any 2 wires and you're back in business. So don't be afraid to wire your own machines.
There's really not a whole lot that goes into a transformer, at least a dry transformer. And it's just lines of copper. They can short out, they can be bad, but you can test for all of that.
Yes. So generally on these transformers, the secondary side is a Y configuration, and the neutral will be bonded to ground. So if you unbond it, and then you can start checking if any of the windings are shorted to ground. You get a false positive if neutral is bonded to ground, and then you start checking if things are shorted to ground. Like, oh man, this thing is shorted out. No, just the secondary side is bonded. So unbond it, check that nothing is shorted to ground, and then you can check that none of the primary windings are shorted to the secondary windings. And then you need what's called a mega or a mega ohm resistance tester that puts like 1,000 volts into the thing, and it's like a resistance check. But you know, I paid like $400 for this transformer. I'm willing to gamble it. I just brought a multimeter and checked that nothing was egregiously grounded out to ground, and then trusted that it wasn't going to go boom. If you really want to be confident, you'd need a mega.
I can attest that if you go into HGR, which happens to be close to my shop here, so I visit it more than is probably good for my wallet, there are tons of transformers just sitting out on the floor there. So um, if nothing else, if your electrician tells you, which I did have one electrician tell me this, that they didn't think they could get a transformer and it might be 6 months, it's not a problem right now, but during like the COVID era, it could have been a problem. Then a used transformer might be a good way to both save money and time.
And you can wire your own machines. It's not rocket science.
Right.
If you're comfortable with it, do not get into things like if you don't have a fundamental understanding of electricity and AC and three-phase electricity, then go research that first. But there's nothing magical about how like CNC machines are wired up. You're like, oh, I don't want to destroy my machine. I don't want to wire it wrong. There's really nothing you can do wrong. If you've taken your multimeter and verified the transformer is putting out the right voltage, there's 3 leads and you can only hook them up. One way is right. And then if you switch any 2, it's the other way. And I don't know of any modern machine that's going to throw a big fit of it being wired the wrong way. It'll either tell you right away, hey, phasing is backwards, or it'll just straight up spin the spindle backwards. And they're like, okay, I guess we should go flip it.
Okay. So at your own risk and under your own responsibility, be willing to do some electrical. Cool. I like that.
It's kind of the general scope of bootstrapping everything. Like the only thing that I have ever hired out was the rigging on the machines, just because I don't own a gigantic Versa lift and a CDL and a semi truck to move machines. But all of the airlines, all the electrical, all of the everything, I just did myself.
Yeah, I did all the air in the shop. We paid an electrician, but also I had to have a whole panel installed, and I wasn't touching the 480. That was my limit. Okay. Mills are lathes. Let's go through that one.
Yes, with caveats, it's limited in its feature set. And a lot of you have seen my videos of like relieving taps or CBN hard turning parts in the Speedio. It is a workable solution that you take a lathe tool, clamp it in the vise, and you put your part in a tool holder. And this is now a lathe.
Okay. The big caveats being, obviously your part has to fit in the collet, and you're not going to get a tailstock. I suppose you can't have a tailstock. Yeah. And other than that, it's just kind of weird, wonky coding to make it work, right?
Yeah, I have a very hacked up lathe post processor that makes Brother Mill G code. And there's no diameter mode. Everything is radius. There's no constant surface split. There's no feed per rev. So it's not a great solution, but it does work.
I don't know if you know Robot Oblivion on Instagram, but he makes really cool trucks for downhill skateboards. And he thought about getting a lathe, but he just needed to make these kingpins, essentially double-ended bolts. And he built a really nice pallet to hold all of his lathe tools, which he puts on a 0 point and then turns all his kingpins. It's a neat setup.
Threading, I don't think threading would work unless your machine had a really good, like, synchronized code, which I don't think any mills do. But you can take a threading die and put it on the table and rigid tap your part into the die. That works.
I'm going to check right now. I think he is threading. I don't remember seeing taps. Now that you mention that, I'm going to ask him. And he's doing this on the Sile with the LNC control. Let's see if I can.
All of the like limitations are purely software. It would be theoretically possible for the control to support all like constant surface split and diameter mode and feed per rev. Just like no control I know of does it.
Yeah, I suspect he's threading with the rigid tap cycle. That's the only way I can think of it working.
Well, you could have a die on the table and tap your part into the die.
Yeah, I don't see that like here. I'll I'll send you a picture of this later, but I'm like looking at his palette right now and it just has normal turning tools and a couple of spot drills on it. And that's it. So I don't see any dies, but I know he's threading these things. So I bet he's rigid tapping into the...
Like progressively stepping it over.
Yes.
And just letting the tool rub on the way back out, I suppose.
Probably, yes. Or he might be like hand coding it to like retract and move away or something. So it's doable, but also like a little harder than an actual lathe. Yeah.
I've made customer parts because I have it pretty well set up now with the custom post, and I've done it enough times I can pretty quickly get the tools set up. It's mostly useful for relieving like tap shanks and stuff. And then you don't even need a post or anything. You just turn the spindle on an MDI and hand wheel the thing against the insert.
Why is that better than just using a grinding wheel?
I wouldn't say it is any better. It's more overkill. It's going to keep it more concentric, and you can actually like hit a real number.
Okay. All right. Okay. So use your mill like a lathe. Bad ideas that are definitely good. Sometimes you need a lathe and you don't have one, so you make one out of a mill. All right. We can fight out this next topic. Gridfinity, all the things. I haven't bought into the Gridfinity system yet. It looks nice. I haven't jumped in. For my end mills, I designed a different system, which I think is inferior to Gridfinity. So there you go.
I would inflict it on the Gridfinity because you are locked to 42 millimeter grid. And so like a 2 wide bin is usually, well, 1 is often not wide enough. And 2 is oftentimes a pretty good compromise, but then 3 is like always way too big. So
Dylan
it's just a large increment.
42 millimeters. Dylan uses a Hoffman system, which you can buy like, it's basically the inverse of Gridfinity. The base looks like the inverse of Gridfinity. And they're all injection molded. To be frank, I am shocked that nobody has created an injection molded Gridfinity base that they just sell. I get that it's not that hard to print them, and people have even set up like the multi-stack printing so you can like make a bunch of them and just walk away. I just can't believe that there's not an injection molded solution out there for it yet.
Free business idea, first listener that gets to this.
Yeah. Somebody make some injection molded Gridfinity bases. Okay. I guess the only other downside to Gridfinity is they just like the bins use a lot of filament and just take a lot of print time. That's a pretty weak objection, but
I have over 1,000 hours on my bamboo printer, pretty much exclusively from printing Gridfinity stuff.
Gridfinity. So all your tooling, collets, everything organized with Gridfinity? Okay. I need to redo my collet storage, so maybe I'll jump into the Gridfinity train for that. All right. Forklifts. Do you own 7 of them now? How many do you have?
Just the one. I had 2 for a little bit,
Okay.
but I am a big fan of electric forklifts. What happens is warehouses buy these things and they run them, and then the battery depletes to a point where it won't last for a full 8-hour shift anymore. And then it's dead in the water to them. And it's like at a point where the battery is worth more than the rest of the forklift to replace it. Mm-hmm. So you can have a lot of used forklifts. They can be had for pretty cheap, and they're electric and the batteries are smoked on them. So buy it. I don't need to run my forklift for an 8-hour shift in the warehouse. I run it for 5 minutes to unload a truck, and then it can go back on the charger. So I don't care if the battery is cooked. I don't have propane tanks to deal with. I don't have an engine to change oil on. I don't have to worry if the battery, the gas trucks have batteries to start them. And I don't have to worry about that being charged, because if you don't use it very much, you're going to drain it more starting the engine than you recharge it running it for 2 minutes. So you're going to have to worry about like having it on a battery tender anyway. It just seems like a whole lot of hassle to have a propane truck when you could have an electric one for cheaper that is lower maintenance, and I can run it inside as long as I want. It'll never gas out my little shop. Like, I like electric forklifts. Seems like all W's, no L's.
Yeah, I would agree with that for the way that I would use a forklift. I get around needing one by my landlord has a forklift in his building, and the few times a year I need one. But it's one of those things where, like, once you have one, everything becomes a forklift solution. Like, oh, sure, I don't need lift gate. Just drop off whatever you need. I'll forklift it in. You need to move around heavy equipment. If you want to reorganize the machines in your shop, assuming your forklift is big enough, I'm guessing you're not moving the Hermley on your own, but
No, but I do have pallet racking, and that is massively useful for storing a lot of things and utilizing the Z dimension instead of floor space.
do you have a man, I guess it would be called a bucket or something for your forklift?
I have a scissor lift.
Okay.
Yeah, so if you're going to be putting airlines or electric in your shop, oh man, rent a scissor lift, or even better, own one. Little electric scissor lift. And this is so much nicer than standing on top of a ladder and constantly moving the ladder. You can be up there with all your tools on the platform and driving it around. Oh man.
Do you
Electric
drive it
scissor
around
lift.
without dropping it, without lowering
Yeah.
it? Yeah. I rented a scissor lift to do all the lighting at the shop here. And I am a little afraid of heights, not a lot. This was a pretty janky scissor lift. I just didn't love, it was like rocking and rolling on me when I was up there. And this one didn't have outrigger legs. I don't know if yours does. The smaller ones typically don't.
No,
But,
you could probably rock back and forth. If you were trying to tip it over, you probably could.
yeah. So anytime I needed to move it, I would lower it and then move it. But it is way, way easier to do things on a scissor lift for sure. They take up a good amount of space in your shop. So if you're not using it very often, can be a problem. But man, when you need to use it, it's super, super handy.
Well, and I have 2,400 square feet right now, so it's not a huge deal to have a scissor lift in the corner.
Right.
Obviously, when you're starting out in your garage, it's a different story.
Right. I don't remember if I used the scissor lift to run the airlines. I don't think I did. Anyway, let's talk about air compressors and airlines and all of that. I have a incredibly janky air compressor setup. It's almost so bad it's embarrassing. The air compressor itself was literally found on the side of the road for free. I swear it's from like 1982 or something. Works fine. It's just a normal piston air compressor, and neither of my machines use very much air, so it can keep up fine. And then my buddy got me a air dryer off of an 18-wheeler. The air dryer is super cool. It is a molecular sieve that both dries the air and removes the oil. And it has its own built-in purge system because that's how it recharges the molecular sieve. So to use it, he wired up a small solid-state relay to a solenoid, and the solenoid actuates the purge system, and it's triggered off the on-off switch, the regulator from the compressor. But it looks, and so, I mean, it works okay. I go directly from the compressor into the dryer through a 10-foot section of copper tubing, which is just coiled around because he told me that their spec requires 10 feet to give it a little bit of time to cool off before it enters the dryer. I don't know if that's to protect the molecular sieve or just that they want to get the temperature down to get the water to condense. I don't know.
Yeah, you're condensing some of the water right off the bat, but then the molecular sieve is going to be less sensitive to air temperature versus a refrigerated dryer, where the entire mechanism of drying is just condensing water out. The molecular sieve is, not condensing the water out versus absorbing it, I guess you'd say, or adsorbing.
Right.
Mr. NASA engineer can tell us the science on this.
I mean, there's not that much science. Like, the molecular sieve is literally just a filter that's small enough to catch water molecules, but big enough to let air molecules through. That's really all it comes down to.
And is there a desiccant stage as well?
There's not. This one, well, I have to say there might be one internal to the thing, but the whole thing works off of what looks like an oil filter for a car, but it's this big. So I actually don't know the mechanics of what goes in there, but it's not a two-stage system. So It's got a big, like 3-gallon purge tank on it. And so what it does is it dries the air, fills that purge tank, and then the valve closes. That seals it off from the main air system. And then it vents the rest of that dry air backwards through the sieve to get the water back out of it. And somehow it separates the oil too. I don't know how it does that. Its purge system is really loud though, because it's an 18-wheeler, so they don't care. So he screwed a little muffler on there that saves that. That makes it a lot quieter. It does purge the oil like straight down onto the floor. So I have a little bucket underneath it to catch that. But not that there's a ton of oil, but it looks super janky though. But like from a purely like theoretical standpoint, it's actually pretty good. Essentially no moist air ever goes into the tank ever, period. It gets dried directly out of the compressor before it ever goes into the tank. And it's worked great. With the one exception being when we installed our 4th axis, we spec'd the wrong tubing, and it was like low pressure tubing instead of high pressure. And inside the machine, like the airline inside the enclosure going to the brake. And it worked fine during the day, the first time we had the 4th on. But then that night, it burst. And the compressor just ran and ran and ran and ran and ran. And it ran till basically it overheated like crazy and tripped the breaker. But that took long enough and everything got hot enough that like heat went all through the system. And there was this series of ridiculous failures, and it took me like 3 days to trace them all down. Obviously, I had to replace the blown line. Nothing on the compressor itself seemed really bad, and like I just tripped the breaker back, like reset the breaker, and that was fine. But then there's a couple of lines that run the copper line, and then a purge line, and a few other things that go to this dryer, including that sort of janky relay. And it turns out the compressor runs on 208, but it turns out that we had used a like 120 relay. And normally that's fine. They can handle a little bit of over voltage for like short periods of time. But this relay is only on when the compressor is running. And so normally the compressor is running for like, I don't know, 1 minute out of every 20 or something. Put a number on it. But all of a sudden it was running for hours and hours and hours. So the relay got fried running over voltage for that long. And then the solenoid got messed up by the really hot air that was going into the sieve. And so I ended up having to like take apart this valving system and clean out the valve, replace an O-ring, replace the solenoid, and then also replace the solid state relay and the purge line that goes from the dryer back to the regulator. Anyway, so I guess it's a great idea, but I probably need to add some kind of a thermal fuse to that system or something like that.
E-stopping the air compressor is part of my leaving the shop routine now as well, because I had a different fiasco. The pressure relief valve on the oil separator on my compressor had like rattled itself loose, and the adjustment had gone down low enough that during normal operating pressure, it would blow. And the first time this ever happened, just of course, had to be when I was taking a nap in the office. And it started spraying like oil mist air out of the relief valve because it's the oil separator on the compressor. Basically, I woke up to the smoke alarm going off, and the entire shop completely hazed out with oil mist. And I didn't know it was oil mist at the time. I thought it was smoke. So like I quick got the dog and the truck out of the shop and opened the big door and turned on a vent fan. And then I went hunting for the fire. And then like I'm looking in all the electrical cabinets of the machines, looking for burnt things. And then I go on the roof looking for like the air conditioner that just burnt up. Couldn't find anything that was on fire. Eventually noticed there was no fire. It was oil mist. Like it suspiciously didn't smell like smoke either. It kind of smelled like oil. That was a not optimal way to wake up from your nap. You go to the shop with your like entire livelihood and all your expensive machines in there, and it's completely, you can't see from one end to the other with smoke.
Is Is there like a fine mist of film of oil covering everything in your shop now?
Not really noticeable beyond like what is in a machine shop normally anyway.
That's good.
And I vented it all out really quickly. I got a huge vent fan set up with the overhead door and just blew the whole place out.
I think about this a good bit. I don't run lights out. I'll leave a machine running with like a long cycle into the night or something. But ever since that incident, I'll actually just throw the breaker on the entire shop power. It's on its own panel, which includes the air compressor when I leave for the night. But as I start, if I'm running a long overnight cycle or something, or when I get automation, I think about this. I'm like, oh, that compressor could go.
All of these weird things that you never think about that are all of a sudden concerns when you're going to not be at the shop or actively monitoring everything. Any possible way coolant can overflow, or this little airline can break, or this sensor can get dirty, or this aspect of the air compressor could be a problem. Like, so many things go into reliably running unattended.
This one's not really a bad idea, but I'm going to mention it now because I feel pretty strongly about it. Almost any shop should have a backup air compressor sitting ready to go, period. But as you start adding automation, like the leverage on your downtime goes through the roof, right? Like if you were planning to run overnight, or like losing one day right now with no automation means I lose 8 hours. Losing one day when I have an automation system that I'm counting on, say, running 16 hours, 20 hours a day, it's like twice as bad, right? And so like, sure, you could probably depending on your machine, you could maybe run over to Home Depot quickly and buy a bunch of shitty air compressors. I think your Hermle uses a lot of air though, doesn't it?
I'm not getting anything off the shelf like home gamer air compressor that's going to make enough CFM.
Yeah.
So I have a fully redundant air compressor that's wired and hooked up to air, and all I have to do is flip the breaker on it and move some ball valves around, and we're flipped.
Right. And I think that's something a lot of shops should invest in. Okay, let's go through some more janky air compressor stuff. At the shop here, I have PEX Apex for my airlines because that's the right thing to do. But in my garage, when I ran the machine there, I just used regular old like Home Depot PEX line for air.
So your PEX lines have like the aluminum liner in them.
In the shop now they do, yeah. Yeah.
Yeah, that's probably the better way. I can attest regular old PEX water lines, perfectly fine.
As long as you're not going to get a lot of UV light on them.
Yes, UV exposure is definitely not good for any plastic.
But the PEX Apex stuff is totally fine. It won't, because of the aluminum liner, you'll be fine. But yeah. I think the risk with PEX stuff is that if it bursts, it could burst badly and like send shards flying.
Oh, no, that's why you never use PVC for airlines.
That's right. That's right.
The PEX is like soft enough, it'll just rupture.
It'll just rupture.
But PVC will like be a pipe bomb.
I do like running PEX, either the PEX Apex stuff, the PEX aluminum PEX that I bought, or just normal. It's so easy. It's way easier than copper. I think it's cheaper than copper by a good bit too.
Oh, massively.
Yeah.
The reason I went for normal PEX is, one, I had all the tools for crimping it from when I remodeled my house, and I can go up the street to Home Depot or Menards and get any fitting I want. Nothing is like a special weird thing that I have to special order off the internet.
Right.
And any NPT adapter or T-fitting or reducer or anything you can imagine is on the shelf up the street. So,
right. So PEX waterline for air. Give it a shot. Okay, the last one is a good one. I think I remember you telling me this, but did you use your compressor to heat your shop?
Yes, I came into the shop one morning and it was like 50 degrees in there, and like the furnace had crapped out overnight. And it was the middle of winter in Wisconsin, so it was cold and getting colder. And my interim solution was I opened up a ball valve to like atmosphere, and I just feathered the ball valve until both compressors could barely keep up with it. They were just both running continuously. And that was enough like supplemental heat that I started gaining temperature in the shop again. And that held me over while I was, initially troubleshooting the rooftop unit and eventually deciding that was a lost cause and installing a different gas heater unit in the shop.
So we're talking like a few days.
Like 8 hours probably from start to finish.
Okay. I mean, I don't think compressors are supposed to run 100% duty cycle for 8 hours like that.
Well, I have all commercial compressors that are 100% duty cycle.
Okay.
Your like Harbor Freight pancake compressor is not going to like that. But my three-phase stuff is all 100% duty cycle.
So you were totally fine.
Like, I'm pushing enough kilowatts that it can produce a meaningful amount of heat.
Right.
A little compressor is just never going to amount to anything more than like running a few light bulbs would. But I have a 7.5, a 5 horse, and an 11 horse that I can run all together. So that's a lot of kilowatts of heat.
Mm-hmm. Well, good for you.
I thought that was clever, though. I came in there, I'm like, okay, shit, it's going to be cold in here. I don't really want the machines to get any colder. I certainly don't need anything to start freezing. And it was like -20 outside in Wisconsin. Like, I would start freezing coolant and having major machine problems. I needed some sort of supplemental heat. And I came up with that idea. I was like, okay, I'm going to make a ball valve that just vents to air, like the atmosphere, and I'm going to feather it until the compressors are going to run constantly. And it worked better than I could have hoped.
Nice. I did freeze the coolant when the Sile was in my garage. It didn't get fully hard frozen. That would have been really bad, but it did get slushy. I bought a heater for the garage for some really cold days at that point. I didn't think to run my compressor nonstop, but
you probably don't have enough power to it that it would meaningfully impact the shop.
Yeah. Well, when it was in my garage, you might be able to make a difference even with my like 3 horse compressor, but okay. Other weird stuff, off-brand window replacements. So this one is a little near and dear to my heart, but the Tesla, wow. The Sile, when it came to ship to me, had just normal sort of tempered glass in the windows, not true safety glass. I found that out from an internet post from Ben, who works for Toolpath now. He threw a part. It went right through the window. Luckily, nobody was hurt. Wasn't a big part, though, and it probably would have killed his kid if his kid had gotten hit with it. Could have, gone through his stomach or something if it had hit him. And that freaked me out pretty good. So I just turned my machine off. I called Sile and was like, what the heck is this? You should have safety glass in here. And they said, they're working on it. And as far as I understand, they do have safety glass in all the machines now. But I just went and ordered new safety glass from Ron's CNC, ronscnc.com. It took them only like 4 days or 5 days to get me new glass. It wasn't super cheap. It was like $1,500 for 4 windows. And then I just swapped them out and put them in the machine. So now I have, I don't know, I got like 1/2 inch thick or 1/4 inch thick. I don't know. They told me it was fine for my 3 horsepower machine. But anyway, you don't have to get replacement windows from the manufacturer. There are other places that will make laminated.
Unless you own a like first generation DMG with the curved giant door window thing. That was a terrible idea.
like it's curved, like the window is curved?
Yeah, like the door is curved and hinges on a curved, like the DMU 75 first generation, I think.
Yeah. Right.
It was a gigantic curved piece of glass. It looks cool, but yeah, you don't want to be the guy that breaks that.
Right.
I like all my machines are just completely flat rectangles of polycarb.
There you go. Okay, and then you have down here to talk about iPad and Tesla screen protectors. Tell me more about this.
Yeah, Big Roto Clear hates me, but you don't have to buy the $2,000 spin window.
Big Roto Clear. Nice.
Yeah. You just literally take an iPad screen protector, or now the Teslas, I guess they have a giant screen in them and you can buy screen protectors for that. It's even bigger than an iPad. So you just stick it to the inside of your machine window and coolant beads up off of it, and chips don't really like ding it up like the polycarb because it's like tempered glass. And nice. You can see right through it. And I have some videos on my Instagram of like the Hermley with through coolant on the entire window. It's just like coolant haze. And then the one little viewport, you can see crystal clear through the iPad screen protector.
Cool. I'm going to have to give that a try. I do a lot of filming through my machine windows, so I'm going to have to give that a try. Speaking of which, I don't have a side window on my Speedio, and I'm tempted to add one. I see no reason not to order a bit of safety glass from Ron CNC and some, support frames from Send Cut Send and bolt it in there. So I may do that. We'll see. Okay. We both tend to find a lot of stuff on Marketplace or at HGR. Have you ever bought anything from HGR?
Yeah, I got my Lister cabinet from HGR.
The one here in Cleveland?
No, there's one in Wisconsin.
Oh, there's one in Wisconsin. Okay.
Watertown.
So Marketplace and HGR finds. What do you think good and what do you think are bad? My bandsaw came from HGR. Did you get a forklift from there?
No. I got the transformers off Marketplace. My piston air compressor is off Marketplace. I got some air tanks, it was an air compressor that the compressor part was dead, so I was just buying the tank for extra air storage, which I just bolted to the wall. It's kind of redneck, but hey, floor space is not free. Basically, it needs to be things that you're okay with risking it being garbage and that you know what you're getting into. But it's certainly a lot cheaper than buying new.
Okay. I do know somebody who bought a forklift off HGR. Works great for him. Pro tip, HGR allows you to return anything you buy within 30 days. I mean, buyer beware, if you're paying them to ship it to you, then you're going to have, or if you're paying to have it shipped to you, you're going to have to pay to have it shipped back. But no questions asked. If you buy it and whatever it is and you're not happy with it, how would you feel about buying a robot or a cobot from HGR?
I don't think it's a good idea.
No, they have a room full of them at the one here.
The initial purchase price on just the cobot is such a small aspect of the overall time and money you're going to have in all the surrounding accessories and end effectors and the cage and the racking and the auto door and just the time in programming and integrating it. I don't think it's worth risking.
Okay. I may do it anyway, but mostly because I want a robot to play with and not to use in a production environment.
It depends on if you're more of a hobbyist / tinkering / you have time to mess with something versus I don't have time for really to do anything anymore. I'm willing to just pay up for the solution that just works.
I think that's an important note. So the Toolpath shop it does not make money for Toolpath. We don't make customer parts. We did for a little while I was learning to be a machinist, but so nowadays I try to spend pretty intelligently or cautiously on this shop because it's an expense for our company. But for you, you could decide to spend a week working on a robot integration, or you could spend that week making money. And you need to balance, can I make money or not? Now, if you don't have enough jobs to keep you busy, then then your own time is not that valuable. But if you are turning away work or could be doing more work if you had automation, it's very hard to justify saving $10,000 or $15,000 when that's, I don't know, say 5 jobs that you could do. Right?
Yeah, $10,000 or $15,000 is a big deal when you're first starting out, but once you're in into actual industrial space, you have native 3-phase power, you have big boy machines. That becomes a week or two of revenue, and then it's not a big deal anymore. And you have to start asking okay, is my time better spent doing what I'm actually good at and using the machines that I have all my overhead tied up in and just making money?
And I think that ties back to what we talked about with tool holders before. When you're first starting out, imagining spending $5,000 on tool holders that, if you tried to measure the utilization of any one of those tools and those holders, it'd be incredibly low, right? If you have, 50 drills and taps, so 100 holders, no one pair of those things is going to get used for more than 3 times a month or something.
Everybody listening needs to have the nuance to evaluate where their shop is in life and whether things are a good idea for them personally to do.
Yeah.
It all matters what scale you're operating at. If this is something you do at in your garage after you're done with your full-time day job, then yeah, probably dropping $5,000 on holders just for shits and giggles is not a good idea.
Would you buy a whole CNC machine from HGR?
No, probably
Never?
not.
No. I know a few people who have pretty successfully gotten either a whole machine or like a through spindle coolant system from HGR. So I've never known anybody who really got screwed buying a machine. I will say that I walked around the one here in Cleveland, and there were 4 or 5 drill tap DMG machines. I can't remember the model number anymore. They look like they would compete with a Speedio. A few of them had full probing in them and everything. They looked like they were a mess. They did not look like they were in great shape. I have no idea how much they would charge for it, but
Yeah, I have kind of a backwards opinion on this. Like a lot of people say when you're first starting out, you buy cheaper used machines. I think when you're first starting out, you only have one machine. You can't afford to have any sort of problems or it's down because I have some weird part that I can't get for 2 weeks. Like you're dead in the water. You got to have really reliable equipment when you're first starting out. And then as you have multiple machines, if you buy a junker and it's down for a while, who cares? I have 3 other machines to run and keep my shop going long. So I think a lot of people start with used machines, then end up getting screwed by it. Like you could have scaled a lot better and more aggressively if you had truly reliable, fast, accurate machines that you don't have to wrestle with or worry about going down.
okay, I think that's fair. If anybody listening has bought a CNC mill from HGR, I know the only machines I know of people have bought have been lathes. I don't know, for some reason it feels less risky to buy a lathe from HGR than a mill, but I have no hard evidence for that. It's purely gut feeling. So
Any machine I buy, I would want to see under power and put an indicator in it and jog it around, look at backlash, check perpendicularity.
okay, so probably no to CNC machines, but I'm sure there are tons of people out there who have at least considered it, if not given it a try. Reach out if you have. All right, let's go on to the next one. 3D printed work holding. Have you ever done it?
I have different variations too. I had some weird angles that I needed to hold a part up at an interesting angle in the vise, and I just 3D printed parallels with that angle. And the parallel had no load on it beyond the weight of the part to hold it in the vise until I clamped the vise, and then the parallels could be removed. And it was just for positioning it at that angle without having to I've done it before as well, where you write a little MDI program to move at the X and Z ratio, like you trig it out for the angle, and then you tap the part around with an indicator until it reads 0.
Oh, interesting. Okay.
You can hold parts at an angle that way and tram them in with the machine moving at an angle if you trig it out. 3D printed parallels that worked really good. And I've also done, they were wedges for a golf club, like a golf club without the shaft attached to it, basically.
Mm-hmm.
And it was like a government work for a friend, just a side project. We wanted to cut different grooves into the face of the golf club. And I had 3D printed a crude match of a nest that the golf club could fit in, but these are just cast. They don't have any defined geometry to them. So it was a crude fixture, if you will. Mm-hmm. And then the difference was made up with a hot glue gun. Just booger a bunch of hot glue in there and fill the gap, and it worked really well.
But then how do you get alignment of the part?
Heidenhain. We love Heidenhain.
Okay.
Yeah,
so
I didn't really probe. Okay. I didn't care if the part was in there flat or straight or anything. You can, on Heidenhain, you probe 3 points and it's a plane. And you say, make this plane flat. And then you take 2 more points and say, make this line straight. And then you probe your XYZ origin and it just works.
Okay.
Everything gets transformed, and it gets really funky because X is no longer X anymore. It's rotated and mixing X and Y to make X because the trunnion had to rotate to make the part flat.
But you don't program it that way.
No, you program it like normal, and the control just handles all the coordinate transformations. And
that's an option you have to buy for Heidenhain, right? No?
It's standard.
Okay. Okay. So if you have Heidenhain, you can get away with that.
Siemens, I believe, can do it too. And everything is air quote possible on Fanuc. It's just such a hassle.
Right. Okay. Fair enough. My point is that not quite as useful as a trick on a 3-axis machine.
Well, the alternative here is if you have a Haas or another machine that supports the machine connection on Fusion, mm-hmm. you can do the live part alignment in Fusion. where it just keeps probing like random points on your part and like continually refining the alignment. And then it orients it in Fusion instead of like the coordinate system in the machine.
Okay. All right. I really like that. First of all, I didn't know that you could do the live connection thing, but you could just probe 3 points and do the math in Fusion too. Like that.
Yeah, so you can just go over to Fusion and like keep tinkering with it until you make the Fusion model match real life. This is another option if you just want to brute force your way into it.
Right. Okay. Yeah. So if you're really trying to deal with something wonky and hopefully the job is worth your time, probe 3 points, write down their coordinates, and then go define those in space in Fusion and define a plane, and then use that for your WCS, and you should be good to go.
What I would do actually is I would make like a different Fusion document and put those points in it, and then measure the angles, like your X rotation and Y rotation angles, and then just go like rotate your part in Fusion on the other document. Probably would be the easy way.
Okay, fair enough.
I guess lesson here is you can make your coordinate system or your part in your cam system match your weird orientation. You don't have to make a fixture that's like truly adjustable to tram it in real life. We have solutions to this.
But on a 3-axis, that basically means you're ball milling everything. On your height and hind, it literally, you could still just face it off or whatever. So, okay, cool. I like that. I would say that's like in case of an emergency kind of thing. On height and hind, it sounds easy enough that just whatever. But
it's good to have in your bag of tricks for when you're painted into a corner.
Right. Yeah. Okay. Any other 3D printed use cases inside the machine that you can think of?
Not for machining, but I like when I've done orders for like a bunch of small pins, and rather than just like chucking them in a Ziploc bag, I 3D printed a tray that they could all fit into. So it's like so low effort and cheap to do that, and like massively increases the customer experience.
Right. Yeah. I 3D printed shipping trays for the IMTS keychains. That worked well. I've seen a couple of other uses of 3D printing in a machine. Some of them are really bad ideas. Some of them are pretty good. I've seen a 3D printed Venturi sucker system to go like, you can make like a Venturi tool with through spindle air and then go suck like chips and coolant out of blind holes. I've seen 3D printed manifolds for like on the Speedios, the coolant is mounted like fixed mounted to the sheet metal. I've seen 3D printed manifolds be used to like be coolant blocks that you mount to the spindle. Thought that one was okay. Eventually, depending on what you're printing with, the coolant is going to eat it alive. But
yeah, I like this better as a proof of concept before you waste time machining a real one. But then long term, you make a metal.
I have also seen, this is a terrible idea, but I have seen somebody run a 3D printed fan, chip fan. This is an awful idea. Scares the crap out of me. I mean, I suppose the worst that happens is it explodes and sends plastic shards all over your enclosure, but still seems bad to me. And then I have also seen a 3D printed like washdown tool, which that one I think I fully support. I have one of the nice washdown tools from Holiday Precision, which I really like and I use sometimes, but the 3D printed one is pretty good. I can't think of any other, I mean, other than like the obvious stuff of like 3D printing handles for like air nozzles and stuff like that.
I've made some 3D printed like toe clamps before.
Oh yeah? They work okay?
To really getting into weird positions on custom fixtures with low volume parts. And it was doing very, very light machining modifications to existing parts.
Okay.
A kind of job I really hate doing. I hate working on other people's parts, but sometimes you got to do it. It works.
Okay. How do you feel about 3D printed tool holder holders for wall mounting?
Not PLA. PLA creeps. You don't want any kind of like long-term static load on PLA. But
okay.
if you use nylon, yeah, sure.
The PLA ones I printed have been totally fine. I've since switched to metal
It's
ones.
probably like massively overkill how strong it is.
Yeah, yeah. But they worked. They worked good. I've since switched over to metal ones from Sencut Send. Mostly because I wanted to double the amount of tools that were in there, and I felt like that was too much for printed ones. But yeah, I'm okay with it. All right. Let's I don't know if you followed my Instagram story on this one, but insect management in a shop is a thing. Hopefully not a thing you have to deal with often, but I had a bee infestation in the shop. And I used the Freddy to clean out. I went into my electrical room and saw like 20 bees in there. And I used a Freddy to deal with it. Worked pretty good. Didn't kill the nest because I didn't know where the nest was, but it did get rid of the bees in the room pretty well. Not an officially approved use of a Freddy, but I have been told that it is acceptable use by Simon. So, yeah. Honestly, I think a Freddy is a tool that I don't think I would want to run a shop without a Freddy. But I saw you recently bought a second shop vac instead.
I do not put any coolant in the shop vac. So that's not for any kind of Freddy use.
Okay. How do you clean up coolant space?
If I spill coolant, I'll suck it up off the ground. But anything that goes in the shop vac is like considered waste. I'm not sucking out my tank and putting the coolant back with my nasty shop vac.
Okay.
But I have a 55-gallon steel drum with the X-Air drum vac kit.
Okay. Yeah.
So it takes compressed air and it's like a Venturi vacuum and it's got a nice hose on it, just like a Freddy has. And you can go into the drum and discharge from the drum with compressed air. And then I have a second drum that has like a mesh. It's like a basket that goes on top of a drum. You get it from McMaster. And I have filter paper on it. So I discharge out of the X-Air drum through the filter paper to get most of the chips. Then I have a submersible Harbor Freight pump in the bottom. And it goes into a cartridge filter, like 10 micron inline filter. And so that pumps the coolant back out through a filter and then back into the tank. So that's how I clean out my tanks.
Okay. And you're probably less than $1,000 into that. I don't know how much that X-Air system is.
That's the bulk of the cost of like $500 on the X-Air kit. And if you were really trying to piecemeal together a cheaper Venturi vacuum generator and a hose, you could. But this is like less than $1,000. You have effectively a Freddy that's just slightly more cumbersome, not quite as nice. It's not one package, it's two drums that you have to move around. And you do need a lot of air. It's thirsty for air. When I was running just the Speedio, I had just a small Harbor Freight compressor. And you'd have to run it for a while, and then you'd have to wait for the air compressor to recharge the tank. Now I have plenty of CFM. I can run it all day, every day if I wanted.
So going back to our earlier discussion about balancing time versus money, if you were restarting again, would you do that system again, or would you buy it?
I would do that again, but now I'm at a point where just like buying a $5,000 Freddy is starting to make a lot more sense.
Okay.
And I'll probably do that soon.
Okay. Pro tip, if you didn't know, Simon said when he was on a recent episode of Within Tolerance that custom paint jobs are free. So you can get it with your shop logo or whatever.
Nice. I really like the Freddy. It's a great design, but they're so expensive when you're first starting out. They're like, I understand the guys that use a shop vac, or I like my X-Air drum vac.
Yeah.
Kind of ghetto Freddy.
I want to make an unapproved modification to my Freddy. Although it's less necessary if I follow your drum filter technique, so I may steal that. The Freddy, like I have the Micro 100 Plus. So they make a Micro and a Micro 100 Plus, which is just slightly larger tank, same thing. And then you go up from there to the EcoVac, and now like an EcoVac is like 12 grand or something. I think I paid like $4 or $5 grand for the Micro 100 Plus. But if I'm doing a full tank clean out, I can fill that thing up very quickly. And if you have the Micro, you'll fill it up like, I don't know, in a minute of sucking up coolant. So I really want to just like weld a hose bung on the side of the thing, and then add like another tank to it, just to give myself more capacity. Hopefully Simon doesn't listen and he doesn't yell at me for this, but I haven't done it yet. I haven't voided my
What if you
warrants.
just had a 55-gallon drum that you brought over and you could discharge some coolant into the drum and then suck up some more from your tank?
Yep. So I think that's probably, especially since you can add apparently a filter basket to it on top of it. So why not built-in suspenders?
And doesn't the Freddy filter on its own?
It does. It does. There's just no reason not to have another filter. Yeah, so that would totally work. It just becomes cumbersome, like you want it all in one package is really what it is. And I think that's what you get when you step up to the EcoVac from the Micro 100 is that it can suck and pump at the same time.
And the tank is just way bigger.
And the tank is way bigger, right? Yeah. Okay, so any other weird unapproved uses for Freddy's that you can think of, or shop vacs?
It would make such a great shop vac for cleaning up like spills on the floor and stuff. I'm so cognizant about coolant contamination that like I would never ever clean out my coolant tank with a shop vac that also cleans up like nasty stuff off my floor. Like everything that touches coolant that's going to go back in the machine has to also be very clean and not nasty.
It's really easy to clean out the inside of our Freddy though.
Okay, it's really not easy to clean out the inside of a sealed 55-gallon drum through the 2-inch NPT bunghole. So that's certainly a downside to the X-Air kit. Like once you get chips into the drum, they're kind of in there. Good luck getting them out.
All right, so Freddy for the win for sure. Yeah, the whole top just comes off the Freddy, and then it's just you just spray it down with some water and scrub it out, and it's clean.
Okay, that's fair then.
Yeah, or pressure wash it if you want to drag it outside or whatever. But yeah, it's really not a big deal. Otherwise, I would have been hesitant when I did the bees. When I took out the bees, I like sprayed that thing full of bee killer, like on the inside and the hose. I wouldn't have done that if I couldn't clean it out after, because I don't want the bee killer in my coolant. All right. Speaking of coolant, coolant mixing and distribution. What do you use?
I have a dosatron, and it's mounted on top of the 55-gallon drum of coolant concentrate in the corner of the shop. And I have more PEX lines everywhere to all the machines. And so I just go over to the wall and turn on the water and take the hose off the wall by the machine and put it in the tank and open the ball valve, and it works. There's no pulling buckets around. There's no hand mixing coolant.
You got your dosatron.
A lot of people I see are doing carts, and they have like a cart with the dosatron and the coolant concentrate, and they pull it over to the machine. I don't know. It's like minimal more effort to just either you're going to plumb water to the machine so that you can power the water to the cart. But at that point, you might as well just make the coolant in one central location and have that line on the wall be coolant instead of water.
I don't know if the PEX is like permanently resistant to coolant or if the coolant would eventually eat it away. I think it'd be fine.
We're about 18 months into my live testing on that, and it has not been a problem.
Okay.
You could be concerned that yourself with that. I guess you might want to do brazed copper instead, and it would certainly last forever.
Mm-hmm. You got your dosatron off eBay?
Yes. New list price on dosatrons is ridiculous. I got a new inbox dosatron for like $400.
That's a great price. I think I paid $300 for a highly used one that I spent an hour cleaning out very thoroughly. They're not complicated. They're very easy to disassemble. They sell rebuild kits for them very affordably. I didn't even bother with that.
What you need to be concerned with if you're going to buy one of these on eBay is they make different models, and some of them only go up to like 3% concentration. So you want the one that goes 1% to 10%. Right. That's useful for coolant.
Right. Do you use RO water?
I do. Only RO water. And
even
the
the
caveat
first
to this conflicted. Different people will tell you different things. Some say it's better to mix with a little bit of minerals in the initial fill up and then top up with RO water. I just go fully RO water, and it had not been a problem.
Interesting.
The RO system I have, like, if you want an RO system that can make any real flow, it's massively expensive. ROs are like inherently really slow to push water through the membrane. So I have like a 50-gallon per day RO system, and I just fill it into a 300-gallon tote.
Like an IBC tote?
Yeah. I have an IBC tote on the pallet racking, and RO system fills into the tote, and then I have a submersible pump in the tote that feeds into the dosatron. I just turn on the pump when I need to use it.
And you can use that IVC tote as the counterbalance when you need a shop crane for your machine.
It's permanently on the pallet racking now because I have the pump wired into it and feed in and feed out for the water.
I do not use RO water, and it hasn't been a problem, but I'm on city water here. My coolant guy who sold me the coolant said we'd be fine. So I'm going with it for now. We'll see if we're not fine.
The answer to this is like, it depends where you are and what your water has for TDS, total dissolved solids.
Right.
There's a lot of minerals in the water around me, so.
I do not have PEX running from my dosatron. I hard mounted my dosatron to the wall though. I'm just pulling out of a 5-gallon bucket. I don't need a 55-gallon drum of coolant yet. Hopefully, maybe someday. And I just bought one of those, like my shop space is fairly small. So I bought one of those expanding, like rubber expanding hoses, and I hooked that up to the output of the dosatron, and I just walk it over to the two machines. That works now. If I had more, I have space for more machines in the shop, and if I sort of walked around the corner and got farther away, then I would run valves around. So
yeah, and the next step beyond what I have going right now is like automatic concentration measuring and level measuring, and like Arduino automating all of this.
I have thought about this too. I've talked to a few people who said that the sensor for measuring concentration is very expensive. But I also found some publications online that said that the resistance of a dissolved oil water mix varies measurably with concentration.
You just make yourself a lookup table.
Yeah. Now you got to be careful. I don't know. There's a whole bunch of caveats there, but the truth is, like, we don't need to be crazy accurate on concentration. Like, even if we had like a 1% swing in either direction, like so plus or minus 1%.
That's way better than most people are doing.
Yeah, that would be fine. So I'll be interested. I haven't had the time to play with this yet. But I suspect that a resistance-based system could be workable. And if so, it would be very, very affordable to re-up an Arduino to just add coolant. When you add coolant, do you do like a 1% add?
Yeah, I crank the dosatron down to 1%.
Okay. Yeah, I do the same thing. The coolant rep told me that there are some, like especially the defoamer, there basically are some consumables in the coolant that just have a pretty heavy a pretty short shelf life.
I'm compensating for carry out mostly.
For carry out, okay.
Yeah.
That's also fair, yeah. You don't completely blow off your parts to perfectly dry before you take them out of the machine?
Well, the chips always have some carry out, and I have a conveyor on the Hermley, which doesn't really carry out much coolant on its own, but it just kind of, it is what it is. You lose a little bit of coolant.
Yeah, that's a good point. I don't have a conveyor, so I don't think about that much. And we don't make enough chips that I can let the chips like really get pretty dry before I scoop them out. But real shops that make real parts have carry out for sure. Although there's another pro tip for Freddy. When I was touring Wes's shop, he took a piece of PVC, shoved it into the bottom of his chip bin, and then uses the Freddy to suck the coolant out of that before he empties it.
Yeah, I don't have standing coolant. Like in the Speedio, I let the chips sit like kind of on the shovel and drain out into the tank. Okay. And on the Hermley, I run the conveyor intermittently so they sit on the uphill part and drain out. So the carryout is just whatever sticks to the surface of the chips.
Got it.
And like when I dump the hopper, there's no standing liquid in the bottom. It's just whatever is clinging to the chips.
Okay.
Like maybe one cup of liquid in the bottom for an entire huge like dump hopper.
Okay. All right.
So.
Okay. I think that covers it. Any other really bad ideas for your shop that you really love?
I just like bootstrapping everything. When you're first starting out, you have a lot more time than money, and like it's not going to hurt you to learn new skills anyway. and just go for it. People are so afraid to learn something new. We're living in an era where you can look anything up on YouTube. Like the internet is way more like slop garbage than it used to be. It's a little bit more difficult to find good content now. It's all like AI word vomit articles when you look something up. It's unfortunate, but you can still learn a lot of stuff for free and just go for it. Like the worst you're going to do is screw it up a little bit. Like, okay, we'll learn how to fix it then.
Cool. All right, Alex. Well, thanks for hanging out with me for, I guess, an hour and a half now, more than that, 2.5 hours. I really enjoyed this. Remind everybody where they can find you on Instagram.
It's at Wisconsin_cam, like CAM.
And if they want to send you work?
My website is wisconsincam.com.
Cool. All right. I'll talk to you soon. Thanks.
Yeah. And it's always great sharing the kind of knowledge we've accumulated over a long period of time. I know this is like particularly revolutionary, but I think this will be a good resource of just like idea vomit for people to think about.
Sure. I hope everybody listening has their own bad ideas that are so bad they're good. Keep an eye out for the release of those open source tool setting macros for the Speedio. We'll get those posted soon.
For sure.
All right. Bye-bye.